On the first day of July in 2025, astronomers working with the Asteroid Terrestrial Impact Last Alert System in Chile reported a faint, slow-moving glow against the background stars. That discovery was formally catalogued as C2025N1 Atlas, later reclassified as 3I Atlas, marking it as only the third interstellar object ever confirmed after Oumuamua in 2017 and Borisov in 2019. From the moment its path was calculated, the evidence was clear. This visitor was moving too fast and on too open a course to remain bound to the Sun. It was interstellar, a messenger from beyond. At discovery, the object was already more than 4 astronomical units from the Sun, about 670 million kilometers away, and it was still active. Its trajectory was hyperbolic, the unmistakable signature of an interloper that would come in, swing around, and then vanish into the dark again, never to return. That alone would have been extraordinary, but further study quickly revealed a set of peculiarities that demanded closer attention. Using the Hubble Space Telescope, astronomers estimated that the nucleus of 3I Atlas might be as large as 3.5 miles across, though it could be far smaller, perhaps no more than a few hundred meters. Measuring the true core of a comet is notoriously difficult, since the faint light of the nucleus is shrouded in a bright coma of gas and dust. In this case, the uncertainties were even larger than usual, leaving room for both modest and massive possibilities. The growing observation arc, extended by researchers combing through earlier images where the comet had been captured unknowingly, allowed astronomers to fix its orbital parameters with higher precision. Perihelion, its closest pass to the Sun, will come on October 29th of 2025 at a distance of 1.36 astronomical units. That places it well inside the orbit of Mars, but still comfortably outside the orbit of Earth. Its closest approach to our planet is projected at nearly 1.8 astronomical units, a safe margin by any conventional measure. For now, the mathematics of celestial mechanics assures us of safety, but mathematics cannot yet account for the unknown behaviors of the object itself. Further ultraviolet observations revealed water activity as well, with molecules pouring off the surface at a rate of more than 1,000 trillion every second. That translates to about 40 kilograms of water vapor per second, an output that requires a surprisingly large fraction of the surface to be actively sublimating. Perhaps as much as 20% of the nucleus is awake, far higher than in many solar system comets. This is no sleepy fragment drifting through space. It is restless, shedding itself into the void. Even the way its dust reflected and polarized light proved unusual. Measurements showed a deep and narrow negative polarization branch, reaching dips beyond what is typically observed in comets or asteroids. The inversion angle was small, the behavior hinting at a dust and ice mixture with properties that may resemble the strange objects on the fringes of our solar system, but not quite matching anything familiar. The portrait that emerges is one of a fast alien traveler, rich in carbon dioxide, highly active and carrying structural and chemical secrets we have never fully encountered. Its path assures that it will not strike Earth, yet its very differences whisper uncertainty. What if the volatile reservoirs inside it are unstable? What if pressure builds and eruptions scatter fragments into new trajectories? What if, as it nears the Sun, the comet shatters into unpredictable clouds of dust, swarms of icy debris that linger in orbits we cannot yet map? The facts we hold today sketch only the outline of the visitor. Within that outline lies a dark core of speculation. An interstellar comet is by definition unknown, forged in a star system we have never seen, carrying material that may never have touched sunlight before now. Every unexpected ratio, every anomalous measurement, is a clue to a mystery larger than itself. For the moment, the data reassures us. No direct collision path, no imminent threat, but reassurance fades when we remember that Oumuamua, too, defied expectations, moving without a coma, and accelerating as if pushed by some unseen mechanism. Borisov, by contrast, behaved like a more typical comet, but even then its chemistry challenged the norm. Now comes Atlas, stranger still, forcing us to confront once more that the rare visitors we can study may not be typical at all. What if they are the exceptions, the anomalies, the outliers, those very qualities that bring them within our sight? The worst-case scenarios do not begin with orbital numbers. They begin with the realization that what we expect may not apply. And so, even though 3I Atlas is fated to miss Earth by hundreds of millions of kilometers, the real question is, can it truly be trusted to behave like anything we know? As the comet moves toward its fated swing around the Sun, one truth becomes unavoidable. Its trajectory is only half the story. The other half lies in what happens as its ices boil, as its nucleus stresses, as forces hidden for eons are unleashed in a single season of sunlight. In the next segment, we will follow its projected path more closely, examining whether its flight through the solar system could place other worlds in danger, and whether even Earth's apparent safety might be more fragile than it seems. The orbit of 3I Atlas has now been traced across hundreds of observations. Its path fit into equations that yield a clear verdict. This comet is a true interstellar messenger, an object untethered to our Sun. Its eccentricity, the measure of how stretched an orbit becomes, is greater than 1.01 at the last calculation, placing it on a hyperbolic course that ensures it will never return. From the distant stars it came, and to the distant stars it will go. But the question is, what happens in the time between? When it was first discovered, the comet was already inbound from deep space, well beyond Jupiter's orbit. As it drifts closer to the Sun, its speed steadily rises, pulled by the central star's gravity. At perihelion, its closest approach on October 29, 2025, it will pass within 1.36 astronomical units of the Sun, inside Mars's orbital radius, but still outside Earth's. At that moment, its velocity relative to the Sun will peak near 43 kilometers per second, faster than almost anything in the solar system, save the planet's orbital speeds themselves. Then, once past perihelion, it will accelerate outward, destined to leave our neighborhood forever. From Earth's perspective, the geometry looks safe. Its minimum distance from our planet will be nearly 1.8 astronomical units, placing us comfortably out of harm's way. That is more than 260 million kilometers of separation, a gulf so vast that even a catastrophic disintegration of the nucleus would leave us untouched, or so the calculations insist. But trajectories are precise only when the forces acting on an object are fully known, and comets have a way of surprising those who track them. As sunlight heats its surface, jets of gas and dust erupt, acting like natural thrusters. These outgassing events can nudge the comet ever so slightly, altering its path in subtle ways. The changes are usually small, measured in fractions of kilometers per second, yet even such small accelerations, integrated over months of travel, can shift where a comet ends up by tens of thousands of kilometers. For a body passing through a crowded planetary system, those shifts matter. They can mean the difference between a clean exit and an unexpected encounter. Oumuamua, the first interstellar object, famously displayed a non-gravitational acceleration as it departed, moving faster than the Sun's pull alone could explain. Astronomers attributed it to outgassing, though no coma was visible. Some suggested more exotic explanations, hydrogen ice evaporating invisibly, or even light cell propulsion. Whatever the cause, the effect was real. If Oumuamua's course could be bent by an invisible hand, how much more could a large, active, volatile-rich comet like 3I Atlas be shifted? Now consider the inner planets it will pass. Its path places it between Mars and Earth, never closer than 1 astronomical unit to either. But Venus lies in the neighborhood as well, orbiting closer to the Sun. Though current models show no encounter, a tiny change in acceleration over the next year could adjust the geometry. Could it swing closer than expected, brushing through Venus's orbital corridor, or grazing the edge of Mars's domain? Even a passing proximity could have effects, scattering dust into planetary atmospheres or disturbing local space environments. And what of Jupiter, the giant sentinel of our system? Though far from perihelion, Jupiter's immense gravity reaches across space. If 3I Atlas passes near enough, even slightly, the planet's pull could alter its outbound path, bending it into a new trajectory. Not a bound orbit, the comet is too fast for that, but perhaps into a direction we had not anticipated, one that carries it closer to us on its way out. Here lies the seed of paranoia. We trust the models because they are grounded in physics, yet the physics depends on forces we cannot fully measure until they happen. A sudden fragmentation event, a hidden pocket of volatile ice that erupts violently, could release jets powerful enough to alter its course. The pieces themselves, if shattered, could take on paths distinct from the original body. One comet becomes many. The predictions, once tight and safe, loosen into a spray of possibilities. Imagine that, sometime after perihelion, 3I Atlas fractures. The core splits into a dozen fragments, each tumbling in slightly different directions. Some drift harmlessly outward. But what if one fragment, only a kilometre across yet massive enough to carry disaster, veers subtly inward, nudged by the asymmetric push of sublimating gases? What if its new path intersects the orbit of Earth, months or years later, a collision course not foreseen because the parent body itself was never aimed at us? Such a possibility cannot be ruled out entirely, for we have seen it before. Comet Shoemaker-Levy 9 shattered under Jupiter's pull in 1992. Its fragments spread out along its orbit like beads on a string. 2 years later, those beads slammed into Jupiter with titanic force, leaving scars larger than Earth on the planet's clouds. Atlas is larger, stranger, and interstellar. What if its shattering plays out not at Jupiter, but in the heart of the inner solar system? Even without fragmentation, dust trails released along its path could seed regions of space with meteoroid streams. Earth does not cross its predicted dust corridor, but predictions rely on stability. A single eruption could tilt a plume into a new direction. Could a stream of microscopic grains, each travelling at interstellar velocity, eventually intersect Earth's orbit? If so, the result would not be a single impact, but a rain of high-speed particles striking our atmosphere, a meteor storm of alien dust. The orbit is calculated, the distances are safe. That is the comfort science offers. Yet history teaches caution. Comets are unpredictable. Their cores are riddled with ices that crack, boil, and explode. Their surfaces hide fractures invisible from afar. Their paths bend under jets we cannot see until they flare. And when the comet is interstellar, when its chemistry is unlike anything local, the unpredictability only deepens. As 3I Atlas approaches the inner system, telescopes across the world will watch every wobble, every change in brightness, every hint of activity. The models will be updated again and again, tightening the predictions. But can we ever be certain, beyond doubt, that no fragment, no dust plume, no sudden course correction lies ahead? That is the unease at the heart of this narrative, not the orbit we see today, but the possibilities waiting in the months to come. The worst case does not demand a direct collision. It only requires that the unexpected intrude, as it so often does with comets. And when the visitor is from beyond the stars, the unexpected may be all we can truly expect. At the heart of every comet lies a nucleus, the solid fragment of ice, dust, and rock that holds the true story of its origin. For 3I Atlas, that nucleus is maddeningly difficult to measure. From Earth's telescopes, even from Hubble's high-altitude perch above the atmosphere, the central body is obscured by its own activity. The coma, a glowing shroud of gas and dust, envelops the nucleus and blurs its dimensions. Early estimates placed the size anywhere from a few hundred meters across to more than 5 kilometers, a spread so wide that it leaves the object's mass uncertain by orders of magnitude. If it is small, closer to half a kilometer, then 3I Atlas may be fragile, a porous body that could crumble as it nears the sun. If it is large, several kilometers, then it carries mass enough to survive perihelion intact, a monolith from another system that will depart our solar system almost unscathed. The truth likely lies somewhere between, yet no one can say for sure, and in that uncertainty lies both reassurance and fear. The coma itself tells part of the story. It appeared early when the comet was still beyond the orbit of Jupiter, suggesting that volatile materials near the surface were boiling away even at great distance. Most comets remain inert until they are closer, their ices lock down until the warmth of the inner system stirs them. That 3I flasher was already awake implies it carries large stores of extremely volatile substances, carbon dioxide among them, that sublimate easily. The coma stretches for tens of thousands of kilometers, a veil of alien gases and dust grains scattering the light of the sun. This activity complicates every measurement. The coma brightens and dims with unpredictable rhythm, masking the nucleus beneath. Jets erupt from the surface, spewing material into space, sculpting asymmetric features in the halo. Each jet represents both a clue and a hazard. The composition of the outflow reveals what lies beneath the crust, but the force of the outflow can push against the nucleus itself, subtly altering its path. A nucleus only a kilometre across, shedding dozens of kilograms of gas and dust each second, is not a passive traveller. It is a self-propelling body, steering itself in ways no orbit calculation can perfectly predict. And what of its interior? A comet's nucleus is not uniform. It is a patchwork of ices and dust, fractured pockets of ancient material preserved from the dawn of its parent star system. Within those pockets lie pressures and stresses waiting for release. When the thermal wave of the sun penetrates the crust, buried volatiles can erupt explosively, breaking the nucleus apart. Some comets have survived dozens of passes, while others, like Comet Ison in 2013, disintegrated entirely during their first close encounter with the sun. 3I Atlas has never been here before. No one knows how it will respond to its first taste of our star's heat. Suppose it holds together. Then we may have before us a rare prize, a nucleus several kilometres wide, a chunk of alien geology that passes through our solar system whole, shedding gas and dust for us to measure. The scientific opportunity would be enormous, the data priceless, but suppose instead that it shatters. Each fragment would carve its own path, some small enough to vanish in days, others large enough to persist for years. What was once a single interstellar comet could become a swarm of alien debris, unpredictable, untracked, and moving at velocities our defences are unprepared to counter. The coma itself could cloak such fragmentation from immediate view. In the blinding halo of dust, pieces of the nucleus could drift apart, hidden until they emerge as separate bodies days or weeks later. By then, the models of its orbit might already be obsolete, our predictions scattered like the comet itself. There is another angle, subtler but equally unsettling. The chemistry of the coma is dominated by carbon dioxide, a volatile far more sensitive to sunlight than water ice. If the nucleus is riddled with CO2 pockets, its eruptions may come not steadily, but in fits, sudden blasts that act like thrusters. Each event could torque the nucleus, alter its spin, even destabilize its structure. Imagine a spinning fragment twisting faster and faster until centrifugal force rips it apart. The coma, the beautiful halo we see from afar, could be hiding a slow, inevitable destruction. And yet one cannot help but ask, what if the nucleus is not fragile, but resilient in a way we do not expect? What if its surface is armoured with a crust, hardened by millennia in interstellar space, preserving a strong, compact core within? Then, instead of disintegrating, it could survive perihelion intact, carrying its secrets back into the void, secrets we glimpse only in the gases that leak from its skin. Such resilience would suggest that the conditions of its birth were harsher, more demanding than those of our own comets. It would suggest a system where comets are forged stronger, tougher, more enduring. If so, what other structures might that system have produced? For all the mystery of the nucleus, one thing is certain. It is active, restless, and volatile. Its coma glows as a sign of its instability, its tendency to erupt, fragment, or evolve in ways we cannot yet predict. And when the very heart of the object is a mystery, the risks multiply, because in every scenario, natural or otherwise, the nucleus is the key. It is the engine that powers the coma, the reservoir that feeds the jets, the potential bomb waiting for a trigger. In the end, the question is simple, though the answer is not, will the nucleus of 3I Atlas endure, or will it collapse? And if it collapses, what fragments will it scatter into the inner solar system, and what hidden trajectories might they take? The worst case begins not with the orbit, nor even the chemistry, but with the possibility of sudden disintegration. And if the nucleus itself is uncertain, then everything we assume about safety may already be a mirage. In the next segment, we will peel back the chemical story further, examining the unusual gases and volatile balance of 3I Atlas, and asking whether its composition hints at dangers we cannot yet see, and whether that chemistry itself could be a message of another kind. Every comet carries with it a chemical fingerprint, a mix of gases and dust that reveals its origin story. For comets of our solar system, water ice tends to dominate. When they awaken, the first great jets are almost always water vapor boiling away into the void, accompanied by traces of carbon monoxide, carbon dioxide, and other volatiles. But with 3I Atlas, the chemistry has already rewritten expectations. Its outgassing is led not by water, but by carbon dioxide, with water playing a secondary role. The ratio of CO2 to H2O is extraordinary, roughly 8:1, placing it among the most carbon dioxide-rich comets ever observed. This ratio hints at a birthplace very different from the nursery that shaped our comets. Carbon dioxide ice sublimates at colder temperatures than water. For Atlas to be so enriched, it likely formed far from its parent star, in the outermost reaches of an alien planetary system where sunlight was weak and volatile ices could condense in abundance. It is, in a sense, a frozen relic of another world's deep frontier. What stories lie locked in that composition? The James Webb Space Telescope has confirmed other gases as well, carbon monoxide, OCS, and subtle traces of organics. Each of these adds to the puzzle. Compared to the comets catalogued in our system, 3I Atlas does not simply fall at one extreme of a known pattern. It occupies a category all its own, a chemical outlier. If Oumuamua confounded us by showing no gases at all, and Borisov reassured us by looking familiar, Atlas unsettles us again. It is neither invisible nor familiar. It is active, loud, and chemically strange. Consider what this means. Every time the sun heats its surface, pockets of CO2 erupt in violent jets. The comet brightens not with the familiar glow of water vapor, but with the spectral fingerprints of carbon dioxide, a gas that responds quickly to small changes in temperature. The result is an object prone to sudden bursts, unpredictable flares, and chaotic variations in brightness. To astronomers, this is fascinating. To those thinking in worst-case terms, it is troubling, because each eruption is a force, each burst of carbon dioxide is a thrust in an unknown direction. There is another layer of paranoia here, one few speak of openly. Carbon dioxide in such concentration may be unusual, but it is not unprecedented. Yet when combined with the comet's interstellar status, it fuels a darker question. What if the composition is not simply natural? What if it has been engineered, or at least selected for its properties? A comet that vents primarily carbon dioxide is one that responds violently to sunlight. It is more erratic, more difficult to model, more prone to unexpected acceleration. Could such a volatile rich mix serve as a disguise, a way to cloak something within an unpredictable shroud of gas and dust? The dust itself adds to the enigma. Polarimetric studies of the light scattered through the coma show behaviors unlike those of typical solar system comets. At certain angles, the polarization dips into negative values more sharply than expected, suggesting dust grains of unusual composition or structure. Some researchers compare it to the properties of distant trans-Neptunian objects. Others argue it is unique, pointing toward mineralogical differences too profound to tie back to anything we know. Dust is the comet's fingerprint as much as gas, and here the fingerprint does not match any catalogue type. If the dust is truly alien in nature, what dangers might it hold? Imagine streams of microscopic grains, accelerated to interstellar velocities, striking the upper atmosphere of a planet. Even if the particles are no larger than sand, their speed alone would amplify their impact energy many times over. A dust storm from 3I Atlas would not be a gentle meteor shower, but a potential hazard to satellites, spacecraft, and high-altitude systems. And if those grains carried complex organics, molecules built in alien star systems, they might seed Earth's skies with chemistry we have never encountered before. Of course, the scientific explanation is more cautious. Most comets vary in composition, many show surprises. A volatile-rich interstellar comet is not impossible, merely rare. Yet in the language of worst-case scenarios, rarity is enough. If a comet's chemistry makes it more likely to fragment, more likely to erupt violently, more likely to scatter dust across unforeseen paths, then chemistry itself becomes a vector of risk. There is another dimension to the paranoia, one rooted not in physical danger but in meaning. Suppose the chemical imbalance is not accidental. Suppose it is a marker, a kind of beacon, something designed to stand out. What if interstellar comets like Oumuamua, Borisov, and now Atlas are not random samples but chosen messengers, each carrying a different story? One inert, one familiar, one volatile and chaotic, a sequence perhaps, a pattern unfolding. If we were being sent a series of objects to test our observation, to provoke our speculation, would they not appear exactly as they have, each one stranger, each one harder to ignore? Even if that idea is dismissed as science fiction, the chemistry of 3I Atlas remains undeniable. It is outgassing furiously, releasing carbon dioxide and water in proportions unseen in most of our comets. Its dust grains scatter light in patterns that unsettle the models. Its nucleus, hidden within, remains an enigma. Chemistry is supposed to be the anchor of certainty, the part of a comet we can measure and classify. Yet here, even chemistry becomes a source of unease. As the sun's heat grows stronger in the weeks before perihelion, that chemistry will only intensify. More jets, more eruptions, more unpredictability. Will it flare so violently that it cracks apart, scattering fragments? Will it brighten to brilliance and then vanish in pieces, like our sun before it? Or will it endure, its volatile stores controlled, its nucleus intact, leaving us with only questions as it departs into the void? The worst-case scenario begins to expand. It is not merely about orbits or impacts. It is about instability, about unpredictability built into the very chemistry of the object. What does it mean to host in our solar system, however briefly, a body that does not behave according to our expectations? And what might happen if the chemistry is not merely unusual, but designed for exactly this, to remain beyond prediction? Comets are often described as dirty snowballs, fragile mixtures of ice and dust that awaken when sunlight strikes them. But that description understates the violence of what actually happens. Outgassing is not gentle evaporation, it is explosive venting, a release of pressure built up over millennia. For 3I Atlas, this process is not only active, it is extreme. Already, even at distances where many solar system comets remain inert, Atlas has been spewing vast quantities of gas into space. Measurements indicate tens of kilograms of water vapor per second, joined by far larger amounts of carbon dioxide. This suggests not just a surface frosting of volatile ice, but deep reservoirs that are venting as the thermal wave of sunlight creeps inward. Each eruption is like a geyser on Earth, except the geyser is kilometers high and powered not by boiling water but by alien chemistry. The physical consequences are profound. Every jet acts as a rocket, exerting thrust on the nucleus. The nucleus itself may spin, wobble, or change trajectory slightly with each burst. For astronomers tracking its path, this introduces small but crucial uncertainties. For those imagining worst cases, it raises darker possibilities. A sudden asymmetric jet could shift its trajectory just enough to alter its outbound path, drawing it closer to a planet than predicted. Or worse, destabilizing the nucleus until it fractures. History offers sobering examples. Comet 17P Holmes underwent an unexpected outburst in 2007, increasing its brightness by a factor of 500,000 in less than 2 days. A quiet, modest comet suddenly became visible to the naked eye, its coma expanding to a size greater than the Sun. If a relatively ordinary comet in our system can erupt so spectacularly, what might an interstellar body with unusual chemistry be capable of? Holmes demonstrated that comets can surprise us, not gradually, but violently, in ways no one anticipated. Imagine Atlas approaching perihelion and undergoing a similar outburst. Instead of brightening modestly, it could flare to brilliance, a vast plume expanding into space. The eruption could release not only gas, but also massive chunks of the nucleus. Some fragments could be ejected into new orbits, no longer following the parent body, but scattering unpredictably. A swarm of alien debris, released in a single event, could pose hazards far removed from the original trajectory. And what of rotation? Jets do not only push, they torque. They spin the nucleus faster and faster, sometimes destabilizing it. Comet 41P Tutul-Giacobini-Crescak doubled its rotation speed in just a few months due to jetting. A body like Atlas, if spun up too quickly, could fly apart under its own centrifugal force. One nucleus could become dozens of fragments, each one carrying its own unpredictable path. There is also the question of timing. Outbursts tend to occur suddenly, with little or no warning. Astronomers may detect subtle brightening hours before, but sometimes eruptions are instantaneous. If Atlas erupts while telescopes are watching, we may catch it in the act. But what if it happens in the blind spot, during the brief window when Earth's telescopes are turned elsewhere, or when sunlight obscures our view? A comet that changes dramatically in a matter of hours could escape notice until the consequences are already unfolding. Now let us follow the paranoia further. Outgassing is natural, but what if it is exploited? Suppose an object designed to masquerade as a comet were engineered with volatile-rich chambers that mimic natural eruptions. Each burst would appear random, chaotic, unmodelled. But beneath the chaos, what if there were intention? A trajectory sculpted not only by gravity, but by carefully timed eruptions, steering the body in ways we assume are natural. To us, the unpredictability would be evidence of volatile chemistry. To an observer who planted it, it would be the camouflage of control. This scenario may sound far-fetched, but it is worth remembering that comets are among the most unpredictable bodies we know. They challenge models, they surprise observers, and they defy neat categorization. If one wished to insert an object into a planetary system without raising suspicion, a comet's disguise would be perfect. Outbursts provide the cover for course corrections. Jets provide plausible deniability for acceleration. Activity provides the smokescreen, both literal and figurative. Even without such speculative layers, the physical risks remain real. Outbursts can send debris into planetary orbits. They can destabilize nuclei into swarms of fragments. They can alter trajectories in ways that models cannot predict. The worst-case scenario is not a neat collision with Earth, but a messy, chaotic disintegration that leaves dangerous debris fields scattered across the inner system. And beyond the physical, there is the psychological. Humanity is accustomed to comets appearing in the sky as slow-moving, predictable visitors. If Atlas erupts into sudden brilliance, dominating the night sky, the effect on public imagination could be profound. Superstition once linked comets to omens of disaster. In the modern era, such an eruption could ignite panic, conspiracy, or both. The object need not strike Earth to leave scars. Fear itself can spread as virally as dust. So we return to the unsettling truth. Outgassing is the heartbeat of a comet, the rhythm by which it lives. But for 3i Atlas, that heartbeat is erratic, explosive, and unpredictable. Each pulse could alter its fate, and by extension, ours. Each eruption could mark a step toward stability or toward chaos. When 3i Atlas was first confirmed as Interstellar, the announcement carried with it an unavoidable echo. We had seen visitors like this only twice before. Each of those earlier encounters had left behind more questions than answers. Together, they form a short lineage of alien messengers. Oumuamua in 2017, Borisov in 2019, and now Atlas in 2025. 3 objects, 3 different faces, none of them matching what scientists had predicted interstellar wanderers would look like. Oumuamua, the first, defied all expectations. Its trajectory was unmistakably interstellar, a hyperbolic orbit carrying it through the solar system at speeds no bound comet could sustain. Yet unlike any comet, it showed no coma, no trail of dust or gas. It reflected sunlight like a bare rock, tumbling in a way that suggested an elongated cigar-like shape, or perhaps a flattened shard. Even stranger, as it receded from the sun, it accelerated slightly, a non-gravitational push too small for rockets, too large to dismiss. Outgassing could explain such an effect, but no gas was ever detected. Oumuamua left as it had come, silent, naked, inexplicable. Some proposed a natural shard of a shattered world. Others whispered of alien sails, of technology disguised as rock. Then came Borisov. Where Oumuamua had been sterile and silent, Borisov blazed with activity. It looked like a typical comet, rich in dust and gas, complete with a long tail stretching across the sky. In many respects, it was comfortingly ordinary, as though the cosmos wanted to reassure us that interstellar objects could be familiar after all. But even Borisov carried anomalies. Its dust grains were larger than expected, its chemical ratios unusual, and its nucleus smaller than its brilliant display suggested. It was both a comet like ours and a comet unlike any we had seen. Now Atlas arrives, and it does not fit either mould. It is active like Borisov, but its chemistry is extreme, dominated by carbon dioxide in a way unseen before. It is not barren like Oumuamua, yet its composition and dust properties make it no ordinary comet. If we imagined a spectrum with Oumuamua at one end and Borisov at the other, Atlas does not sit in the middle. It occupies a third point, a triangle rather than a line. Each visitor expands the map of possibilities instead of clarifying it. This raises a troubling thought. Are we seeing a random sampling of interstellar debris, or are we being shown a sequence? One silent rock, one familiar comet, one volatile rich anomaly, each unique, each stranger than the last. If we were dealing with mere chance, would not at least one of these visitors conform neatly to expectations? Why then do all three resist categorization? Why do they all carry anomalies? Some astronomers argue that interstellar objects are biased samples. Only the brightest, most unusual, or most conveniently aligned with Earth's observing geometry are noticed. If so, then we should expect them to be odd. But there is another interpretation, one more unsettling. What if they are not random? What if each one carries a different lesson, a different signal, as though some agency or some cosmic filter ensures that only the strange ones reach us? Consider the progression. Oumuamua arrives first, the quiet intruder, slipping through with no warning, sparking speculation of alien craft. Then Borisov, the reassuring comet, reminding us that nature can explain much. And now Atlas, bigger, louder, chemically bizarre, stirring both scientific fascination and quiet paranoia. 3 steps, 3 escalating challenges to our sense of certainty. What happens if there is a fourth? Will it conform, finally, to expectations, or will it push the envelope further, presenting anomalies too large to dismiss? Is Atlas itself a prelude, a warning that the interstellar traffic we are beginning to glimpse is not simple debris, but part of a deeper story? There is another pattern worth noting. The gaps between discoveries are shrinking. Oumuamua in 2017, Borisov in 2019, Atlas in 2025. The first 2 were separated by just 2 years, the next by 6. As survey telescopes grow more sensitive, more interstellar objects are bound to be found, but the timing, to some, feels almost orchestrated. What if this is not simply a matter of improved instruments, but of increased frequency? What if the galaxy is sending more of them, or allowing more of them through? The paranoia lies not only in the anomalies, but in the implications. If every interstellar object we have seen so far has been extraordinary, then we must ask, are we seeing the true face of interstellar debris, or are we being curated, shown only what is meant to be seen? The thought may be unsettling, but it lingers, whispering between the lines of orbital calculations and spectral data. Atlas stands now as the latest chapter in this trilogy of enigma. Its coma glows with alien chemistry, its nucleus hides uncertainties, and its trajectory threads through our system like a test. It does not look like Oumuamua, and it does not behave like Borisov. It is a third kind. And if 3 data points suggest a pattern, the pattern here is clear. Every interstellar object we meet defies expectations. What then should we expect next? And what if the worst case is not a single event, but a cascade, a series of visitors, each more disruptive than the last, each gnawing away at our sense of safety in the void? Long before telescopes revealed their icy hearts, comets were feared as omens of destruction. The ancients saw blazing apparitions crossing the night sky, unpredictable and untamed, and they were not entirely wrong to tremble. Even stripped of myth, comets remain dangerous. They are volatile, unstable, and prone to sudden transformation. For an object as alien as 3i Atlas, those dangers may only be amplified. The most obvious threat is fragmentation. Comets are fragile bodies, riddled with fractures and hollow cavities. They are held together not by strength, but by cohesion of ice and dust, a precarious structure preserved in the cold. As they approach the sun, heat seeps inward, pockets of gas erupt, pressures build, and the nucleus can tear itself apart. Some comets disintegrate quietly, scattering dust into space. Others shatter violently, creating swarms of fragments. Each fragment becomes a new body, its trajectory diverging slightly from the parent's path. In a worst-case scenario, one of those fragments might veer into an orbit that threatens a planet, or linger in space long after the original comet has passed, a delayed hazard drifting unseen. Another danger is dust itself. Even when a comet remains whole, it sheds billions of particles, forming streams that stretch across space. If a planet crosses such a stream, its atmosphere becomes a shield against a storm of meteors. Most burn harmlessly as shooting stars, but even small grains can damage satellites, spacecraft, and sensitive electronics. Earth has experienced meteor storms in the past, some so intense they look like fire falling from the sky. These storms came from comets born in our system, moving at local velocities. Imagine the same effect seeded by an interstellar comet, its dust grains striking at higher speeds, carrying unfamiliar mineral compositions, and arriving on trajectories never mapped before. Gas emissions add their own risks. Comets release carbon monoxide, carbon dioxide, and other volatiles, each interacting with solar radiation in complex ways. Their tails can stretch millions of kilometers, sometimes crossing planetary orbits. If Earth were to move through such a tail, the effect might be little more than a sky filled with strange colors, auroras triggered by alien particles. But in extreme cases, dense plasma sheets from comets have been speculated to interfere with magnetic fields, disrupt radio signals, or affect upper atmosphere chemistry. These risks are theoretical, but with an object as unusual as Atlas, they cannot be dismissed entirely. There are also mechanical dangers. Comets are not smooth. Their surfaces are jagged, sculpted by eruptions, cliffs, and collapse pits. As chunks break away, they create secondary projectiles, blocks of ice and stone tumbling through space. Some of these can be large, tens or hundreds of meters across. A fragment of that size entering Earth's atmosphere would release energy equivalent to nuclear weapons. A larger one, a kilometer or more, could devastate a continent. Though Atlas itself is not on a collision course, fragmentation could scatter debris unpredictably. One piece drifting into a resonant orbit might return decades later, transformed from harmless visitor into deadly intruder. The unpredictability of cometary behavior compounds these risks. Some brighten steadily, predictable in their rise and fall. Others, like Comet 17P Holmes, explode without warning. Outbursts can increase brightness by factors of hundreds of thousands, signs of violent restructuring within. In such cases, the hazard is not only physical, but also observational. If a comet can change so suddenly, our ability to track and predict its behavior may lag behind reality. With an interstellar body, this delay could be even more critical. But there is one more peril to consider, quieter and subtler. Comets carry complex organic molecules, hydrocarbons, amino acids, precursors of life itself. When they strike planets, they deliver this chemistry wholesale, perhaps seeding worlds with the ingredients for biology. But if they deliver the wrong chemistry, alien in form and incompatible with local life, the effects could be corrosive. It is speculation, but worth imagining. Dust storms seeded with organics from another star, drifting into Earth's atmosphere. What reactions might those molecules trigger? Could they act as poisons, as mutagens, as catalysts of processes we do not yet understand? All of these hazards, fragmentation, dust, gas, impacts, organics, are known to science. They belong to comets in general, not only to Atlas. Yet when the comet comes from interstellar space, the uncertainties grow sharper. Its chemistry is stranger, its dust more unfamiliar, its behavior less predictable. Each natural risk becomes an amplified version of itself, a reminder that the dangers of comets are not limited to their paths. They are inherent to their very nature. So when astronomers reassure us that 3i Atlas will not hit Earth, they are not wrong. but they are only answering the simplest question. The real dangers lie in the chaos of fragmentation, the scattering of debris, the seeding of dust, and the release of alien chemistry. Those dangers do not require a collision. They only require the comet to be itself. And if the natural risks alone are troubling, the worst-case scenarios grow darker still when we imagine the extreme edge of possibility. In the next segment, we will push further, exploring what would happen if 3i Atlas does not behave within even the loose boundaries of cometary unpredictability, if it becomes not just an active body, but a catastrophic one. When scientists model comets, they often build their predictions on precedent, what past comets have done, how they have behaved when heated, how they have fractured under stress. But precedent fails when the sample is too small. 3 interstellar visitors cannot define a reliable pattern. That is why 3i Atlas forces us to peer into the worst-case edge of imagination, where natural disasters escalate into catastrophic scenarios. One possibility is wholesale disintegration near perihelion. Comet ISO in 2013 approached the Sun with great promise, expected to become the comet of the century. Instead, as it drew close, its nucleus succumbed to thermal stress. In hours, it fragmented, brightened, and then vanished into dust. If Atlas follows this path, its sudden destruction could be spectacular, a glowing cloud expanding into millions of kilometers of space. But the worst case is not its disappearance. It is what follows. Dust clouds that large can linger for months, creating corridors of debris. If even a fraction of that cloud intersects planetary orbits, the solar system inherits a new unpredictable meteor hazard. Consider another scenario, asymmetric collapse. A nucleus weakened by uneven heating may break apart not into fine dust, but into large fragments, kilometer-sized shards hurled into divergent paths. Some could be flung outward harmlessly, but others could settle into orbits resonant with planets, bound not for immediate impact, but for future encounters. Jupiter's pull could reshape their courses, scattering alien debris deeper into the system. Earth, safe from the parent body, might face danger years or decades later from children born of its collapse. Then there is rotational instability. Jets erupting from specific points on the surface could spin the nucleus faster and faster. Once centrifugal force exceeds structural strength, the nucleus would rip apart violently. The fragment, still massive, would inherit both the forward velocity of the parent and the spin-induced divergence. Instead of one predictable hyperbolic escape, we would have dozens of unpredictable paths, some perhaps drawn closer to inner worlds. It would be like a celestial grenade, the detonation scattering hazards across the solar system. And yet physical catastrophe is not the only risk. Imagine the dust itself, not as inert grit, but as chemical payload. Atlas is already rich in carbon dioxide and carries organics. Suppose within its matrix are molecules forged in alien environments, stable in interstellar cold but reactive in sunlight. When released, they could behave in ways we do not anticipate. What if these compounds catalyze reactions in planetary atmospheres? What if, scattered into Earth's air, they bond or break apart in ways that affect ozone, weather, or even biology? It is speculation, yes, but speculation seeded in the reality that comets deliver chemistry wherever they go. The scale of catastrophe need not be planetary to be devastating. A dust plume drifting into Earth's orbit at the wrong time could cripple satellites, blind sensors, or ignite panic with meteor storms streaking across the skies. Even without a single impact, civilization could feel the effects, communications lost, satellites crippled, skies filled with unexplained fire. The natural hazard of a disintegrating comet becomes indistinguishable from the signature of an attack. And there is the psychological factor. Humanity is not prepared to watch an alien object unravel before its eyes. The sight of a comet fragmenting, glowing brighter than any star, its debris cloud stretching across the heavens, this would ignite speculation far beyond science. Was it natural? Was it a message? Was it something we triggered simply by observing? In the absence of certainty, fear breeds its own catastrophes. These worst-case scenarios rest on physics, not fantasy. They have happened before with comets in our own system. The only difference is that Atlas is interstellar, carrying chemistry and structure we do not know. That unknown magnifies every possibility. Where local comets follow familiar rules, Atlas may carry rules of its own. So we arrive at a sobering truth. The catastrophic potential of 3I Atlas does not require intention. Nature alone is sufficient. Heat, pressure, rotation, fragmentation, each mechanism is a trigger, waiting for the right moment. The only question is whether Atlas survives perihelion or becomes a disaster unfolding in real time. But what if we push even further? What if, instead of considering only fragments, dust and chemical risks, we ask the harder question: could an interstellar comet ever collide directly with a planet? The odds may be small, but the consequences would be unthinkable. And even if Earth is safe, what if Mars, Venus, or another world is not? Astronomers speak with confidence when they say that 3I Atlas will not strike Earth. Its closest approach is nearly 1.8 astronomical units away, a gulf so wide that even a violent deviation would not bring it close to our orbit. But the solar system is not Earth alone. Mars, Venus, and the giants all trace their own paths, and a single miscalculation or outburst could tilt the comet closer to one of them. To imagine the worst case, we must follow those lines of possibility to their ends. Begin with Mars. Its orbit lies near the corridor of Atlas's passage, though predictions show a miss by millions of kilometers. Yet comets have a way of straying. If Atlas were to fragment near perihelion, one of its shards might be nudged into a course intersecting the Martian orbit. Mars has weathered impacts before, its surface scarred by craters from billions of years of bombardment. A kilometer-wide fragment of Atlas slamming into the red planet at interstellar speeds would release energies beyond comprehension, scarring the planet anew, perhaps lofting dust into the thin atmosphere to alter its climate for decades. Humanity's robotic emissaries on Mars, rovers, landers, orbiters, would be silent witnesses to a catastrophe written in alien ice. Consider Venus. Its thick atmosphere offers no protection from a direct strike. A large fragment plunging into that shroud would trigger shockwaves that ripple around the planet, searing heat followed by weeks of glowing skies. Though Earth would not feel the impact directly, the aftermath might be visible from our world. Venus shining strangely in the night sky, brighter than ever, cloaked in a haze that speaks of disaster. The psychological effect on humanity would be profound. To watch a sister planet wounded by an interstellar visitor, to know that it could just as easily have been us. Then there is Jupiter. The giant's massive gravity well acts as both shield and snare. It draws comets in, captures fragments, and sometimes obliterates them against its vast bulk. Shoemaker Levy 9 proved the spectacle in 1994 when its broken pieces rained down into Jupiter's clouds, leaving scars larger than Earth. If Atlas or any part of it were drawn into Jupiter's grip, the event would be visible across the solar system. But here lies the worst-case twist. Jupiter's pull could also act as a slingshot, redirecting fragments onto new paths. A shard that might have drifted harmlessly outward could instead be bent back toward the inner planets. The giant, in protecting us, might inadvertently doom us. Even Saturn, farther out, plays a role. Its gravity, less commanding than Jupiter's but still immense, could tug on outbound debris, scattering fragments into unpredictable directions. The solar system is a web of gravitational influences, and into that web Atlas now threads itself. One shift, one fracture, one outburst, and the geometry changes. Now stretch the thought further. What if not a fragment, but the main body itself veered off course? The odds are infinitesimal, but in worst-case speculation, infinitesimal does not mean zero. A trajectory altered by a massive outburst could, in theory, bend closer to a planetary orbit. The timescales are short, the distance is great, but unpredictability is the constant companion of comets. What would impact truly mean? A nucleus several kilometers across, traveling at 40 kilometers per second, carries kinetic energy on a scale that dwarfs human comprehension. Striking Earth, it would end civilization. Striking Mars, it could alter the planet's environment in ways that challenge future colonization. Striking Jupiter or Saturn, it would create scars and storms, but also potentially scatter debris into new orbits. Any planetary impact is not a closed event. It echoes through the solar system in altered trajectories, in dust storms, in new threats born from the violence. The paranoia grows sharper when we recall that interstellar objects travel faster than local comets. Their impact energies are proportionally greater. A collision would not only be devastating, it would be unlike anything in planetary history, an alien bullet from a foreign star system slamming into a world unprepared. No models of Earth's past extinctions, no craters on the Moon, quite capture the scale of such an event. This would be unprecedented, a scar not only on a planet, but on our understanding of safety in the cosmos. And here lies the deepest unease. If such an impact were to occur on Mars or Venus, humanity would watch in real time. We would see another planet struck down by a visitor from the stars, a spectacle that would remind us of our fragility, our vulnerability. Even if Earth were spared, the psychological impact would be enormous. Could we trust that the next interstellar object would miss us as well? Or would we live in dread, waiting for the one that does not? For now, astronomers assure us Atlas will pass safely, its path clear of planetary orbits. But assurance is not certainty. Comets have fooled us before, and this one is stranger than most. A collision is unlikely, but in the calculus of catastrophe, unlikely does not mean impossible. And if it happened, the consequences would reverberate for centuries. When people think of comet hazards, they imagine a catastrophic impact, a world-ending strike from a massive fragment. But comets are dangerous in subtler ways too. Sometimes the most insidious threats are not from mountains of ice and rock, but from clouds of microscopic dust that drift unseen through the void. For 3I Atlas, a comet already known for violent activity and unusual chemistry, dust may be its most enduring legacy. Every eruption from its surface sends particles into space, grains ranging from submicron specks to pebbles large enough to ping off spacecraft. Unlike the nucleus, which follows a defined orbit, dust spreads out, forming vast trails that can stretch for millions of kilometers. These streams persist long after the comet itself has moved on, hanging in space like invisible rivers of debris. Planets that pass through them are bathed in showers of meteoroids, each grain striking at cosmic speeds. On Earth, such encounters create meteor showers, the Perseids, Leonids, Geminids. These displays of falling stars are the debris of comets long gone, dust trails Earth crosses each year. Most are harmless, their fiery streaks nothing more than grains burning up in the atmosphere. But the harmlessness comes with two conditions. The grains are relatively slow, and Earth's protective blanket of air shields us. With Atlas, neither condition is guaranteed. Interstellar dust moves faster. Its particles inherit the comet's hyperbolic velocity, entering the solar system at tens of kilometers per second faster than typical meteoroids. An impact at those speeds multiplies the energy released. A grain no larger than a sand particle can punch into satellites like a bullet, puncturing delicate instruments or shredding solar panels. Spacecraft in orbit around Earth, or traveling deeper into space, could be scarred, crippled, or destroyed by showers of particles too small to see. And Earth's atmosphere, while protective, is not invincible. Tiny grains burn, but larger fragments, centimeter-sized or more, can survive the plunge, reaching the ground as meteorites. Most would be harmless rocks. But what if they carried alien chemistry? What if their mineralogy included compounds unstable in Earth's environment, reacting violently with air or water? Even without toxicity, the delivery of alien organics could alter ecosystems in ways we cannot predict. A rain of foreign dust is not just a spectacle, it is an experiment in planetary contamination. The paranoia grows sharper when one considers the possibility of dense plumes. Cometary outbursts do not release dust evenly, they vent in concentrated streams, jets that spray into space in narrow corridors. If Earth were to cross such a plume, the result could be a meteor storm, thousands of meteors visible each hour, a sky ablaze. It would be beautiful, terrifying, and potentially destructive. For satellites, such storms are lethal. For ground observers, they are omens of disaster, impossible to ignore. Atlas's dust also carries another danger: plasma interaction. Dust grains are not inert. When bathed in solar radiation, they become charged, interacting with magnetic fields. Clouds of ionized dust can disturb local plasma environments, interfering with radio waves, distorting signals, even inducing currents in power grids. These effects are rare, but when an object as chemically strange as Atlas releases vast quantities of dust and gas, the interactions become harder to dismiss. Could an interstellar dust storm interfere with Earth's technological infrastructure, not by striking directly, but by disrupting the invisible webs of communication and electricity we depend on? Even if Earth itself is spared, other planets or spacecraft may not be. Mars, with its thin atmosphere, is vulnerable to dust impacts that reach the surface. The Moon, airless and exposed, would be peppered directly by interstellar grains, its regolith altered in subtle ways. Spacecraft orbiting other worlds, from Jupiter's probes to satellites around Venus, could be caught in storms they were never designed to endure. The hazard is not confined to Earth. It extends to every outpost we have scattered into space. And here lies a chilling thought. Dust is not easily tracked. Large bodies can be followed, their orbits plotted with precision. Dust streams are diffuse, invisible until they strike. Predicting them requires detailed knowledge of the comet's eruptions, information we often lack. In the worst case, humanity could find itself blindsided. One night the sky is clear, the next it burns with fire, satellites fail, signals flicker, and no one saw it coming. For 3I Atlas, the dust it leaves behind may outlast its visit. The nucleus will pass through the solar system in a matter of months, but its debris could linger for decades, drifting along orbits reshaped by planets, spiraling into unexpected paths. Long after the comet is gone, its dust could remain, a hidden minefield seeded across the solar system. So the question becomes not whether Atlas itself will hit us, but whether the invisible storm it creates will. And unlike the comet's nucleus, dust offers no singular target to deflect, no body to study in advance. It is a swarm, untrackable, unpredictable, and unstoppable once released. The worst case may not come from the nucleus at all, but from the countless tiny fragments that slip through the void. In the next segment, we will expand beyond dust and fragments to consider how comets interact with the Sun itself, how plasma, radiation, and stellar winds might turn 3I Atlas into something stranger, more dangerous, and more unpredictable than any calculation can capture. Every comet is, in the end, a creature of the Sun. Its behavior is dictated by the star's heat, its shape carved by radiation, its path twisted by plasma winds. For 3I Atlas, approaching from interstellar space with volatile reservoirs unlike anything we know, the Sun is both executioner and interrogator. As perihelion approaches, the violence of that interrogation will intensify, and the comet's response may not be what we expect. The solar wind, a stream of charged particles pouring out from the Sun at hundreds of kilometers per second, slams into cometary atmospheres, shaping their tails and igniting their plasma envelopes. Cometary ions glow, fluorescing in strange colors as they interact with the storm. But the process is not one way. Comets disrupt the solar wind, carving out cavities, shock fronts, and turbulent regions. These disturbances ripple outward, sometimes detectable even from Earth. When the comet is massive, active, and chemically unusual, the effect can be dramatic. For Atlas, whose coma already shows violent CO2-driven activity, the interaction may be especially chaotic. Carbon dioxide and carbon monoxide are easily ionized, feeding plasma tails that whip millions of kilometers through space. These tails can detach suddenly, snapped away by shifts in the solar wind, only to regrow hours later. The spectacle is dazzling. The danger lies in the unpredictability. Detached plasma sheets can travel independently, moving like ghostly sails across planetary orbits. If Earth or another world were to intersect one, the results could be subtle yet profound. Disturbances to magnetic fields, spikes of radiation, interference in satellites and communications. The Sun's radiation also plays another role. It can trigger delayed explosions. As heat penetrates deeper into the nucleus, layers once frozen for eons awaken all at once. Volatile pockets erupt with sudden fury, jets of gas tearing into space, sometimes in quantities large enough to destabilize the nucleus itself. For a fragile body like a comet, this process is the prelude to disintegration. For an interstellar comet built of unfamiliar chemistry, the outcome may be stranger still. There is precedent for solar-triggered catastrophe. Comet Lovejoy in 2011 plunged into the Sun's atmosphere, expected to perish, yet it emerged broken but blazing, its tail severed, its nucleus scarred. Comet Isidine in 2013 approached closer still and disintegrated entirely, shredded into dust by the Sun's glare. These were solar system comets, familiar in composition. Atlas, with its alien chemistry, may carry volatiles that ignite at different thresholds, making its solar encounter unpredictable in both timing and scale. And then there is solar radiation pressure. Light itself pushes on comets, a constant yet gentle force. For small dust grains, the pressure can exceed the Sun's gravity, flinging them outward at high speed. This creates the classic dust tail, but it also means fragments of Atlas may be scattered in unexpected directions, accelerated away from the parent nucleus by sunlight alone. Dust clouds driven by radiation pressure are difficult to track, spreading wide, crossing planetary paths long after the comet is gone. Paranoia deepens when we consider that radiation is not uniform. The Sun flares, belches, and storms. Coronal mass ejections hurl billions of tons of plasma into space, expanding at hundreds of kilometers per second. If Atlas crosses paths with such an ejection, the encounter could strip its coma violently, perhaps trigger its fragmentation. But what if it does the reverse? What if the comet itself, with its rich volatile gases, acts as a seed, amplifying or redirecting the solar storm? Could it, by coincidence or design, send waves of plasma toward Earth at amplified intensity? Speculation sharpens further still. Suppose the chemistry of Atlas is tuned, by chance or otherwise, to react explosively when struck by specific wavelengths of solar radiation. Ultraviolet light, extreme at perihelion, could trigger cascading reactions in exotic ices, producing bursts of energy far beyond normal sublimation. To us, it would look like a natural outburst. But to an imaginative mind, it could appear as something more deliberate, an object that responds to the star like a mechanism waiting for its trigger. Even in purely natural terms, the Sun is a dangerous partner. Every comet must endure its wrath, and many do not survive. But Atlas is larger, richer, stranger. Its interaction with the Sun may create plasma disturbances on scales we have never seen, unpredictable tails of dust and ion, eruptions timed with solar flares, cascades of debris carried across the solar system by the breath of the star. For now, the models treat the Sun as a passive influence, a force to calculate, not a variable to fear. But history reminds us that the Sun is not constant. It is capricious, storming, roaring, unpredictable in its own right. And when an interstellar body falls under its gaze, the combination becomes volatile. The question then is whether Atlas will survive its solar encounter, or whether the Sun will unmake it. And if it is unmade, whether the destruction will be quiet or catastrophic. Because sometimes the worst case is not what a comet does by itself, but what it becomes when the Sun strikes back. Gravity is the silent architect of the solar system. It binds the planets, guides the moons, and sculpts the paths of comets. For 3I Atlas, hurtling through our neighborhood on a hyperbolic trajectory, gravity is both a constant and a wild card. Its orbit is not bound, yet its journey is influenced at every turn by the invisible pull of massive bodies. And in those pulls lies the potential for outcomes stranger than the clean exit astronomers predict. The most significant player is Jupiter. Its gravity dominates the system, extending its reach across hundreds of millions of kilometers. Comets passing near the giant often leave altered forever, some captured into new orbits, others slung into the void, still others shattered under tidal forces. If Atlas were to drift even slightly closer to Jupiter than expected, its outbound path could change dramatically. It would not be captured, its interstellar speed is too high, but it could be redirected, bent onto a trajectory closer to Earth's orbital corridor, or tilted in ways that bring it into resonance with other planets. One pass near Jupiter can ripple into consequences years later. Even Mars plays a role. The red planet is smaller, weaker in gravity, but its orbit lies close to the corridor Atlas will travel. If a fragment were to shear off and drift toward Mars, the planet's pull could shepherd it, altering its future path. A fragment nudged by Mars could, in theory, find itself in an orbit that intersects Earth's years later, long after the parent body is gone. Venus too cannot be ignored. Orbiting closer to the Sun, it lies within the range of potential dust trails. Its thick atmosphere would burn most debris, but gravitational encounters with Venus could subtly redirect fragments into paths Earth might later cross. Even small tugs accumulate, shifting trajectories that begin harmless but end in hazard. And then there is Saturn. Though distant, its immense bulk exerts its own influence. A fragment that passes near Jupiter might be passed along like a ball, bent again by Saturn, scattering unpredictably. The giant planets do not simply pull, they conspire, their combined gravity weaving webs that can trap or redirect debris in ways that defy intuition. The solar system becomes a billiard table, the interstellar comet a cue ball, whose trajectory alters with each unseen touch. The paranoia emerges when one considers the margins. Astronomers calculate Atlas's orbit with exquisite precision, but comets do not follow precision. Outgassing nudges, fragmentation, radiation pressure, all act as forces outside the equations. A change of only a few kilometers per second, applied at the right moment, could shift its course by millions of kilometers downstream. And in a system filled with planetary gravity wells, small shifts can snowball. What if a fragment, nudged slightly by an outburst, drifts near Jupiter at just the right angle? Instead of flying harmlessly outward, it could be slingshotted inward toward the terrestrial planets. Such an event would be rare, but not impossible. Jupiter has redirected comets before, sometimes sending them toward Earth. It is our shield, but also our gambler's dice. Every close pass is a throw that could land in our favor or against it. There is another unsettling possibility. Gravitational interactions can capture fragments temporarily, trapping them in loops around the Sun before releasing them again. A piece of Atlas, once thought gone, could linger bound not permanently, but long enough to become a hidden resident of our system. It might circle for years or decades, masquerading as a local comet, until one day its orbit crosses ours. The parent body is gone, but its offspring remains, a ghost of the interstellar traveller, a delayed hazard. And what if Atlas itself is more massive than we think? If its nucleus is closer to 5 kilometers across rather than 1, its gravitational interactions with passing planets would be correspondingly stronger. Even without capture, such a mass could perturb smaller bodies, asteroids or comets, that already lurk near resonant orbits. It could set off chains of events invisible now, but fated to unfold over centuries. The comet itself may leave, but the gravitational disturbances it sows could echo long after. Paranoia, at this point, takes on a conspiratorial shade. What if the trajectory of Atlas is not accidental at all? Its path threads between Mars and Earth, close enough to be studied, far enough to seem safe. But the corridor it follows places it under the influence of multiple planets in sequence, as though aligned to maximize interaction. Suppose this is not coincidence. Suppose its route is calculated, not by us, but by forces or agents unknown, to pass through gravitational zones where its fragments could be captured, scattered, or redirected. A placement so precise that it guarantees consequences, not immediately, but eventually. The fear is not only in what Atlas does now, but in what it sets in motion. Gravity is patient. A small fragment redirected today may not reach Earth for decades, but when it does, it will seem random, unforeseen, inevitable. We will trace it back, calculate its origin, and find the ghost of Three-Eye Atlas lurking in its past. So when astronomers tell us the comet will miss Earth, they speak truth, but only for the nucleus, only for now. Gravity is not finished. The solar system is not static. Atlas is not alone. Every encounter, every tug, every slingshot is a new throw of the dice. And dice, when thrown long enough, eventually land in ways we would rather they did not. The greatest mysteries of a comet lie not on its surface but beneath it. A nucleus is a frozen archive, layered with ices that condensed in the far reaches of its birth system. For Three-Eye Atlas, those ices are alien. They did not form in our sun's nursery, but around another star, in conditions we can only imagine. The gases it releases, water, carbon dioxide, carbon monoxide, are only the first hints of what lies buried. The true danger may come from volatiles we have never encountered before, hidden deep until sunlight awakens them. Volatility is the key. Different ices vaporize at different temperatures. Water requires warmth, but carbon monoxide escapes in deep cold. Exotic compounds, methane, nitrogen, hydrogen cyanide, sublimate at thresholds in between. A comet's behavior is dictated by this chemistry. If its composition is unfamiliar, its activity will be unpredictable. For Atlas, with its extraordinary ratio of carbon dioxide to water, unpredictability is already written into its character. Now imagine what happens as the thermal wave penetrates deeper. At first, only the surface layers respond, releasing gases slowly, but as weeks pass, heat seeps into reservoirs sealed for eons. Pressures rise, trapped beneath crusts of dust and ice. When the crust finally ruptures, the release is sudden and violent, a geyser of alien vapor, a shockwave of dust. For ordinary comets, such outbursts can brighten them by factors of thousands. For Atlas, richer in volatiles, the eruption could be catastrophic. Fragments would fly, jets would torque the nucleus, the entire body might shatter, and in each shard the process would continue, heat finding new pockets, triggering new explosions. The comet would become not a single body, but a cascade of detonations, spreading debris through the solar system in a storm no model could predict. The paranoia grows sharper when we consider what those ices might actually be. Suppose Atlas carries compounds not stable in our system, but stable in the cold of interstellar space. Exotic hydrates, alien nitrides, complex organics, molecules that break down explosively when exposed to our sun. To us, the eruptions would look like natural cometary activity. But what if, to another intelligence, they would look like signals, eruptions timed not by randomness, but by chemistry tuned to respond at precise thresholds of heat and radiation? Even without speculation, the natural hazards are clear. A sudden explosion could fling fragments onto new trajectories. Some could be ejected sunward, disintegrating into plasma storms. Others could be hurled outward, crossing planetary orbits long after the main body is gone. Dust streams could thicken, dense enough to seed meteor storms across entire worlds. The chaos would unfold not as a singular event, but as an unfolding cascade of shocks, each triggered by hidden reservoirs of volatile ice. Consider hydrogen cyanide, a toxic compound found in some solar system comets. A comet rich in HCN, erupting into Earth's atmosphere, would not wipe out humanity, but it could inject enough poison to disrupt ecosystems on a local or regional scale. Now imagine Atlas carrying alien analogues of such compounds, compounds we do not even know to test for. Its dust and gas might be inert, or it might not. Each eruption could be a release of substances our biology has never faced, raining chemistry from another star onto our skies. Volatility also means instability. Even if Atlas does not shatter, its eruptions could alter its spin, destabilize its orbit, or mask its true nucleus beneath clouds of dust. Observers might think it intact long after it has broken, tracking an illusion while the fragments diverge unseen. A single hidden eruption could make the difference between safety and disaster, between a clean pass and a scattering of hazards into the inner system. The paranoia whispers louder when we realize how little we know. Atlas is the third interstellar visitor we have ever seen. Its chemistry is strange, its activity extreme, its nucleus uncertain. For all our instruments, we cannot probe its interior. We do not know what lies beneath its crust. We do not know what ices slumber there. We do not know which ones will awaken, or when. It is a vault sealed by the cold of deep space, and the sun is the thief prying it open. What if the vault holds something we cannot handle? What if its eruption is not only bright but transformative, releasing more than dust and gas? What if it is carrying materials deliberately, whether by chance of its formation or by intention of design? What if the sudden eruption is not the end of the comet, but the beginning of its true purpose? For now, these remain questions, but they are questions sharpened by history. Comets erupt, comets fragment, comets surprise. Atlas is a comet like no other, born in an alien system, rich in chemistry we have never seen. Its hidden volatiles are the seeds of uncertainty, the fuse of potential catastrophe. So far, we have kept our speculation within the bounds of natural hazards. Fragmentation, dust, volatiles, dangers born of physics and chemistry. But 3i Atlas carries with it a more unsettling possibility, one that lingers like a shadow behind every calculation. What if it is not entirely natural? What if its presence, its chemistry, its very path through our solar system is deliberate? This line of thought is not new. When Oumuamua passed in 2017, its strangeness, its lack of coma, its unexplained acceleration led some to suggest it might be artificial, not a spaceship in the cinematic sense, but perhaps a derelict, a probe, or even a fragment of alien technology adrift in the void. The idea sparked controversy, embraced by some, dismissed by others, but it left a residue of unease. If even one interstellar visitor can raise such questions, then why not another? Atlas invites the same suspicion. Its chemistry is abnormal, its activity extreme, its dust peculiar. Its trajectory threads it through the solar system in a corridor close enough for study, but distant enough for safety, as if placed with care. To the cautious mind, this could be coincidence. To the paranoid, it could be choreography. Imagine a civilization that has mastered interstellar travel, not with ships of steel and engines of fire, but with subtlety. Why risk sending craft when nature provides the vessels? Comets travel between stars naturally. If one wished to observe or probe another system, what better disguise than a comet? A nucleus seeded with instruments, shielded by ice, propelled by outgassing. To us, it would appear as just another volatile, rich body. To them, it would be a messenger, hidden in plain sight. Suppose the chemistry itself is a clue. A comet dominated by carbon dioxide behaves erratically, its eruptions violent and unpredictable. This instability would make its trajectory harder to model, harder to dismiss as ordinary. Could the unusual ratio of gases be intentional, a way to ensure we take notice? Could the dust properties, so different from our comets, be designed to spark suspicion? Perhaps the anomalies are not flaws in our understanding, but signals meant to stand out, patterns written into chemistry. The paranoia deepens when we recall the sequence of visitors. Oumuamua, the silent rock. Borisov, the familiar comet. Atlas, the volatile anomaly. 3 objects, 3 distinct behaviors. A progression that could be random, or could be a pattern. First, a test of our attention. Then, a baseline of familiarity. Finally, a disruption, a stranger that refuses categorization. If this is a message, it is unfolding step by step, each visitor stranger than the last. Skeptics will argue against such thinking, and rightly so. Extraordinary claims demand extraordinary evidence. The burden of proof lies heavy, but absence of proof is not proof of absence. To dismiss the possibility outright is to ignore the unease these objects stir in us. Science must entertain hypotheses, however unsettling, if only to test them. Not a spacecraft bristling with technology, but something subtler. A probe designed to awaken near stars, to study or transmit, to seed dust rich in information. Its nucleus could contain structures invisible beneath its crust, instruments shielded by ice. As sunlight penetrates, those instruments could activate, hidden within the natural eruption of gases. To us, it would look like volatile activity. To them, it would be function. The notion stretches credibility, yet it is not implausible in principle. Humanity itself has contemplated using comets as vessels, hollowing them out for protection against radiation, using their ices for fuel. If we can imagine it with our limited reach, what might an older civilization have done with millennia of head start? If Atlas is natural, then we are safe for now. If it is artificial, then its arrival is not chance, it is intent, and intent demands interpretation. Why here? Why now? Why this path, this chemistry, this spectacle of activity? These questions hang unanswered, but they cannot be dismissed. In the worst case, the alien hypothesis is not only true but hostile. A comet could conceal more than instruments. It could conceal weapons. A fragment guided subtly toward a planet could strike with devastating force, disguised as natural impact. Outgassing could serve as camouflage for course corrections. Dust seeded with toxins could masquerade as meteor storms. The paranoia grows darker, but it is not without logic. Even if the intent is benign, the implications are staggering. To know that another civilization has reached us, that it has disguised itself as a comet, that it watches as we scramble to study, this would transform our understanding of our place in the cosmos. Fear and wonder would collide, reshaping culture, science and belief, and so Atlas becomes not just a comet, but a test, natural or artificial, random or deliberate, messenger or intruder. These questions form the core of the alien hypothesis, the speculation that shadows every interstellar visitor. If we permit ourselves to follow the alien hypothesis to its next step, we arrive at a question that has haunted astronomers since Oumuamua first slipped through our system. What if these visitors are not random fragments of alien geology, but watchers? Not ships in the way we imagine them, but sentinels, devices seeded among the stars, designed to pass quietly through planetary systems and observe. The concept is chilling in its simplicity. A civilization capable of interstellar engineering might never need to send crewed vessels across the void. Instead, it could seed comets and asteroids with instruments, letting the galaxy's natural currents carry them. They would masquerade as debris until activated by the warmth of a nearby star. The eruption of volatiles would not only propel them, but also serve as cover for whatever work they were designed to perform. Free I Atlas, with its peculiar chemistry and extreme activity, invites such speculation. Its orbit threads it between the terrestrial planets, at a distance close enough for study, but far enough to pose no overt threat. To us, this is a relief. But what if that placement is intentional? What if its mission is not to collide, but to watch, to measure electromagnetic emissions, to scan planetary surfaces, to listen for signals in the noise of our civilization? Imagine a probe buried deep within the nucleus, dormant for millions of years, powered by layered ice, and awakened only when sunlight penetrates. Its sensors unfurl as the comet erupts, hidden in the chaos of dust and gas. To our telescopes it would appear as natural outgassing. To the builders it would be a transmission, a burst of data relayed back through the void. The comet itself would be both disguise and engine, shielding the sentinel until its moment arrived. The paranoia intensifies when we recall the sequence of interstellar visitors. What if Oumuamua was the first sentinel, silent and enigmatic, slipping past us undetected until it was already leaving? What if Borisov was the control, a baseline comet meant to measure how we respond to the familiar? And now Atlas, louder, stranger, watching how we handle something anomalous. Each object not random, but part of a survey, an interstellar reconnaissance mission disguised as natural phenomena. If so, then Atlas's chemistry may not be accident at all. Carbon dioxide-driven activity produces violent, unpredictable jets. This makes the comet harder to model, ensuring our astronomers expend effort tracking it, analysing it, pointing our best instruments at it. What better way to provoke attention? If the purpose is to make us look, then it has succeeded. We have trained Hubble, James Webb, Swift, and countless ground-based telescopes on this alien wanderer. It is under observation, but perhaps the reverse is also true. Suppose the Sentinel hypothesis is correct. Then the next question follows. What is it looking for? Is it listening for the radio chatter of a young technological species? Is it scanning our biosphere, gauging the chemistry of our air, the glow of our cities, the warmth of our machines? Or is it not observing at all, but signaling, sending a message across the stars, reporting that our system hosts a world that shines with artificial light? The worst case is not only that Atlas is a probe, but that it is one of many, a network of watchers seeded through the galaxy, each disguised as a comet, each waiting for its moment to awaken. We may not be studying them, they may be studying us, and if that is true, then the interstellar visitors we have seen so far are not random encounters. They are check-ins, periodic observations, data points in a survey we did not consent to join. Even without hostile intent, the implications are unsettling. To know we are being watched from within, by something disguised as a fragment of ice, is to realize that the boundary between natural and artificial is thinner than we thought. We cannot look at a comet without wondering whether it is more than it seems. Our skies are no longer merely astronomical, they are ambiguous, layered with suspicion. And if there is intent beyond observation, a sentinel can watch, but it can also trigger. What if Atlas is not only here to measure, but to act when conditions are met? To awaken not only sensors but systems designed to broadcast, to manipulate, or to release? If so, then its perihelion may not be the climax of a natural orbit, but the activation of something greater. The paranoia whispers one more possibility. What if the Sentinel is not for us at all? What if Atlas is transmitting not to Earth but to others, signaling its builders that a new star system has been reached, a habitable planet catalogued, a young species detected? If so, then the comet is not only a visitor, but a beacon, a message in motion, and that message once sent cannot be unsent. If 3i Atlas were only a disguised observer, a silent sentinel drifting through our system, the implications would already be staggering. But paranoia always asks the next question. What if it is more than a watcher? What if its presence carries conditions, triggers waiting for alignment, moments when its role shifts from passive to active? Comets respond to sunlight with eruptions of gas and dust, but what if beneath that natural process lies something tuned to activate only under specific circumstances? Heat alone might not be the only trigger. What if the object is waiting for a precise alignment when Earth, the Sun, and the comet fall into a geometry that allows for maximum observation or communication? What if perihelion is not just an orbital milestone, but a switch, a moment chosen long before we ever measured its path? There are eerie precedents for such thinking. Oumuamua displayed an unexplained acceleration as it left the inner solar system. Natural explanations were proposed: outgassing, thermal recoil, radiation pressure, yet none fit perfectly, leaving behind the suspicion that its course was not entirely passive. Atlas, with its violent carbon dioxide eruptions, presents opportunities for similar anomalies. But what if those eruptions are not random? What if they are structured, timed, controlled in ways our instruments mistake for natural variability? Suppose the trigger is electromagnetic. Earth radiates a constant stream of radio signals into space, the unintentional beacon of our civilization. Could Atlas carry systems designed to listen for those signals, to awaken when they pass a certain threshold? Perhaps its arrival in 2025 is no coincidence at all, but a response, a programmed journey across light years, timed to intersect with a moment when our transmissions were detectable, when our species had reached a level worth observing, or perhaps the trigger lies within the comet's chemistry itself. What if certain volatiles are not simply ices, but engineered compounds, stable in interstellar cold yet reactive under the ultraviolet glare of our sun? As Atlas nears perihelion, those compounds could undergo transformations, releasing not only gas and dust, but signals, radio pulses, laser-like emissions, data encoded in plasma waves. To our eyes, it would look like cometary activity. To its builders, it would be communication. Paranoia sharpens further when we imagine intentional delay. What if Atlas carries systems that do not awaken near the Sun, but after it has passed, when fragments have scattered across the solar system? Each fragment could be a seed, inert until it drifts close to a planet or moon. The true trigger might not be the Sun at all, but proximity to a world worth studying or striking. The darker interpretation is obvious. A comet is the perfect Trojan horse. No defense system would treat it as hostile. Its approach is slow, predictable, catalogued months in advance. But if it carried within it mechanisms that activate at perihelion, mechanisms capable of steering fragments or dispersing payloads, then its disguise would be flawless. Outgassing would provide both propulsion and cover. Eruptions would appear natural. Only the outcomes would betray the truth. And what outcomes? A probe that awakens to listen is one possibility, but a probe that awakens to act is another. Imagine fragments deliberately steered toward planets, collisions engineered to look like accidents of celestial mechanics. Imagine dust seeded not only with organics, but with self-replicating nanostructures, invisible in a meteor storm until they reach the ground. Imagine a comet that is not simply passing through, but deploying. Even if we temper these fears, the paranoia refuses to fade, because triggers do not have to be alien to be dangerous. Natural ones are peril enough. The sun's heat, a solar flare, a tidal tug from Jupiter. Any could awaken hidden reservoirs of volatile ice, unleashing explosions beyond our ability to predict. In those moments, Atlas's fate could pivot, and with it, the fate of any planet in its path. And yet we cannot help but notice the timing. 3 interstellar objects in less than a decade, each stranger than the last, each provoking deeper questions. Are we simply witnessing the statistics of discovery, or are we brushing against the edges of something orchestrated? If so, then Atlas may not only be an object but an event. Its arrival timed, its behavior staged, its triggers waiting for the curtain to rise. If 3i Atlas is more than just ice and dust, then the question naturally follows, could it be sending signals? Could the violent eruptions we see as random jets of gas actually carry structured emissions, hidden messages pulsing through the electromagnetic noise of space? Telescopes already record comets in a spectrum of wavelengths: radio, infrared, ultraviolet. Every gas has its fingerprint, every ion its glow. But woven within that natural chorus could be patterns, rhythms too regular, fluctuations too precise, bursts too short-lived to be explained by chemistry alone. If a civilization wanted to hide a signal, where better than inside a phenomenon already expected to be noisy? Our instruments would record the emission lines of carbon dioxide, the fluorescence of water vapor, the static of solar-wind interaction. A narrow beam of information, encoded within, could pass unnoticed unless we looked with suspicion. And what of reception? A sentinel does not only speak, it listens. Earth is loud in the radio spectrum, a planet wrapped in a cocoon of artificial chatter. Television broadcasts, radar pulses, satellite communications, all leak into space. By now, a century of signals has spilled outward nearly 100 light-years. Suppose Atlas carries systems tuned to those frequencies, waiting to confirm the presence of a technological civilization before awakening. As it passes through our solar system, it may be soaking in every whisper of our machines, compiling a profile of Earth as an inhabited world. The paranoia turns darker when we imagine it not only listening, but responding. Outbursts of gas could modulate plasma waves, creating pulses detectable across space. To us, they would appear as sudden variations in cometary activity. To others, they might be coherent messages, signals aimed at distant receivers far beyond our reach. What if, right now, Atlas is reporting back, announcing that it has found what it came to find? Even if the comet is natural, the thought unsettles. Outgassing does produce radio emissions, sometimes chaotic, sometimes patterned. Cometary comas can generate cometary hiss, a radio phenomenon first detected during space probe encounters. If Atlas is erupting at unprecedented scales, it could be producing signals strong enough to be mistaken or disguised as communication. The line between natural and artificial is thin, blurred by phenomena we do not fully understand. There is also the possibility of optical signaling. Brightening events could be timed, bursts of luminosity occurring at intervals that appear natural to us but carry meaning in a broader context. A flash every rotation, a sequence of jets from different hemispheres, a pattern inscribed in dust and gas. To our eyes it is chaotic, to theirs it might be language. And what if we are the recipients? What if Atlas is not transmitting outward but downward toward Earth, toward us? Could we be missing a signal hidden in its activity, dismissing as cometary noise what might be deliberate modulation? Perhaps the narrow polarization anomalies observed in its dust are not quirks of grain size, but encoding. Perhaps the high carbon dioxide ratio is not merely chemistry, but part of a designed broadcast medium, chosen for its spectral visibility across light years. The worst case is not that Atlas is silent, but that it is speaking, and we are failing to understand. Or worse, that we do understand, and those who interpret the signals choose silence, deeming humanity unready for what the comet has to say. Even more chilling is the possibility that Atlas is not alone in its communication. What if other interstellar objects have already signaled? Oumuamua, Borisov, did we fail to catch their voices in the static? Was their passage through our skies not random but part of a coordinated relay, each one transmitting, each one listening? If so, Atlas is not a solitary visitor, but a link in a chain, a node in a galactic network we barely perceive. The paranoia is complete when we ask the hardest question, what if the message is not benign? To transmit that a world is inhabited is also to announce it as a target. If Atlas is a beacon, then the signal it carries may not be one of greeting, but one of marking, a flag in the void planted in orbit around the Sun, declaring there is life here and it has reached a stage worth noticing. To whom that message is addressed, we cannot know. If 3I Atlas carries intent, if it is more than a drifting relic, then the greatest danger is not that it signals, but that it does so without our recognition. The disguise of a comet is perfect. Eruptions of gas, flickers of brightness, radio hiss, these are things we expect, things we can explain away. But inside that noise could lie patterns, and in those patterns meaning. The camouflage is complete, precisely because we believe we understand it. Detectability becomes a paradox. On one hand, we have some of the most powerful instruments ever built aimed at Atlas. Hubble peering from orbit, James Webb tuned to infrared, arrays of ground-based telescopes watching every change in brightness. If the comet behaves oddly, we will record it. If it erupts, we will measure its gas. If it fragments, we will map its pieces. We are watching as we have never watched before, and yet that scrutiny may not be enough. For the disguise to succeed, the anomalies must look natural. Consider polarization. Atlas exhibits unusual scattering of light, a narrow negative polarization branch not seen in typical comets. To astronomers, this suggests unfamiliar dust composition. But what if that is not all? Polarization is a carrier of information. Laser communication on Earth often encodes signals in polarization states. If an advanced civilization wished to hide transmission, encoding it in the dust halo of a comet would be ideal. We would dismiss it as an optical quirk while the message flowed unnoticed. Radio emissions offer another channel. Comets interacting with the solar wind produce natural radio noise, chaotic but measurable. But chaos can be patterned. A deliberate signal buried in cometary hiss could travel alongside natural static. Our instruments, tuned to catalogue cometary emissions, would record it as noise. Only by suspecting intention would we ever look closer, and suspicion is exactly what science disciplines itself against. Even dust itself can be camouflage. The composition of Atlas's grains is alien, its ratios unlike anything in our system. Dust trails could carry encoded patterns, clusters arranged in ways that reveal geometry, structures hidden in distribution. To us they are meteoroid streams. To someone looking with different intent, they could be maps, diagrams, even instructions. The paranoia thickens when we remember how little we can actually see. Atlas is millions of kilometers away, its nucleus shrouded in coma. We cannot land on it, we cannot probe it directly, we cannot see beneath the veil. Everything we know comes from reflected light, from spectra, from indirect measurements. If it carried a structure, a device, an artificial chamber deep inside, we would never know. The disguise is perfect, not because it is flawless, but because it is uncheckable. And there is another layer, deliberate subtlety. If Atlas were broadcasting openly, blasting signals across the spectrum, we would notice. But what if its builders wanted the opposite? What if the message is not for us but for others, distant receivers already listening? Then detectability by Earth is irrelevant. The transmission could be directional, focused outward, timed to perihelion when energy release is greatest. We would see only natural eruptions, while elsewhere across the stars, the signal is received with clarity. Now imagine the inverse. What if Atlas is not sending, but listening? Its instruments hidden in the nucleus, its sensors shielded by ice, its coma the antenna through which signals are caught. In that case, our inability to detect transmission is no reassurance. It may be recording everything. Our radar pings, our spacecraft telemetry, the hum of Earth's radio chatter. It may remain silent to us, yet not to those who await its report. Silence can be as deliberate as speech. The worst case is not that Atlas hides secrets we cannot see, but that we never even think to look for them. Science operates on assumptions. When the assumption is that the comet is natural, every anomaly is explained as chemistry or physics. Paranoia asks, what if that assumption is wrong? Then every dismissal becomes a confirmation of the disguise. We prove its naturalness because we never allow for its artifice. and so Atlas may pass through the solar system without us ever realizing what it was. We will catalogue its orbit, publish papers on its chemistry, debate its dust, and watch it leave. We will call it mysterious but natural, and if it is not natural, then its mission will be complete. The Sentinel will have passed, undetected, its camouflage intact. Worst-case scenarios rarely unfold as single events. Catastrophes compound. A natural disaster collides with human vulnerability. An accident coincides with design. With 3i Atlas, the most unsettling possibility is not that it is wholly natural or wholly artificial, but that it could be both, an interstellar body carrying risks of chemistry and fragmentation, while also serving as something more deliberate. In such a hybrid, intent and accident blur until we cannot tell where physics ends and design begins. Start with the natural. Atlas is volatile rich, prone to violent eruptions. It could fragment at perihelion, scattering shards across the inner solar system. Dust storms could follow, meteoroid streams seeded in unpredictable corridors. Satellites, spacecraft, and even planets might one day pass through those clouds. The risks are real, written in cometary history. Now imagine that within this chaos lies structure. Suppose the eruptions are not entirely random, but tuned, whether by natural coincidence or engineered design, to create specific effects. Jets that seem chaotic to us might, under careful analysis, reveal patterned intervals. Brightness variations dismissed as noise might be modulated signals. Dust trails that appear diffuse could contain alignments, geometric clusters invisible unless one knows to search. The chaos becomes camouflage for order hidden in plain sight. What would such a blending mean? It would mean that every eruption carries two possibilities at once, a burst of volatile gas and a transmission. Every fragment could be both a piece of cometary debris and a payload. Every dust grain could be both inert mineral and encoded particle. The very unpredictability of comets, long a source of frustration for astronomers, becomes the perfect disguise. Hybrid danger is not only speculative, nature itself has offered examples. Shoemaker-Levy 9 fragmented naturally, yet its pieces struck Jupiter with apocalyptic force, creating a display that could be seen across the solar system. If a civilization wished to mask an intentional strike, using a comet as the delivery system would be perfect. Impact would look like coincidence, destruction like inevitability. The line between natural catastrophe and deliberate action would vanish. Paranoia sharpens further when we consider timing. Atlas arrives in 2025, in an era when humanity is deeply dependent on satellites, communications, and global infrastructure. A dust storm seeded into our orbit would cripple not only machines, but economies. A fragment striking Mars would devastate not only a planet, but our future ambitions of colonization. Even if no alien intent exists, the coincidence of timing is uncomfortable. But if intent does exist, then the timing could be chosen, its path calculated centuries ago to intersect with our age of vulnerability. Consider also the role of signals. Suppose Atlas transmits during its perihelion outbursts. To us, it would look like noise, indistinguishable from natural radio hiss. But to others, it would be a clear message. Earth has reached a threshold. The signal could travel outward, while dust and debris travel inward. One half of the hybrid is communication, the other hazard. Together they create an event that marks and tests us, both scientifically and existentially. The greatest danger is interpretive. If Atlas fragments naturally, but coincides with anomalies, strange signals, odd alignments, humanity may not be able to agree on what happened. Some will see coincidence, others will see design. The debate itself could fracture societies, splitting trust in science, eroding confidence in institutions. Fear would become its own disaster, a psychological collapse layered atop physical risk. In the hybrid scenario, there is no clean separation. Natural eruptions become suspicious. Dust storms feel engineered. Impacts look intentional. Every phenomenon is doubled, every explanation shadowed by its mirror. And in that doubling lies paranoia, the sense that we are never seeing the whole truth. So we face two dangers at once. The first is physical, the volatility of a comet born in alien cold, erupting unpredictably as it nears our sun. The second is interpretive, the suspicion that what appears natural may not be. Whether or not Atlas carries intent, the fact that it could creates an environment of permanent unease. The comet becomes not just a traveller, but a test, a mirror of our fears, and this is the worst case of all. Not a collision, not a dust storm, not a transmission, but the fusion of all of them into a single event. A hybrid disaster where nature and design overlap, where every eruption feels like both accident and purpose, where catastrophe is indistinguishable from conspiracy. If 3i Atlas were to unravel into catastrophe, whether by natural fragmentation, engineered intent, or some hybrid in between, the next question is unavoidable. What could humanity do about it? Could we defend ourselves against the worst case, or are we, for all our telescopes and technology, still vulnerable to the silent arrival of something from the stars? Earth's planetary defense systems are in their infancy. We track asteroids and comets with networks of telescopes. Pan-STARRS in Hawaii, Catalina Sky Survey in Arizona, Atlas in Hawaii and Chile. Together they scan the skies each night, searching for moving dots that betray the presence of near-Earth objects. These surveys have catalogued thousands of asteroids, mapping potential hazards decades in advance. But interstellar objects like 3i Atlas do not play by those rules. They arrive unannounced, screaming into the solar system at hyperbolic speeds, leaving little time to prepare. Even when we detect them, our options are limited. NASA's Double Asteroid Redirection Test, DART, proved in 2022 that a kinetic impactor can nudge an asteroid off course. The success was historic, but it applied to a small local target with years of preparation. For a fast-moving interstellar comet, detection windows are shorter, distances are greater, and speeds are higher. By the time Atlas was confirmed as interstellar, it was already deep into the solar system, months from perihelion. There is no time to mount a deflection mission. Nuclear options exist in theory. A nuclear detonation near a comet's surface could vaporize material, pushing it off course. But again, timing is everything. Such missions require years of planning, years we do not have. Worse, if the comet fragments instead of deflecting, we may trade one target for many. A single 5-kilometer nucleus is terrible. A swarm of 100-meter shards could be worse. Planetary defense is built on probabilities, but comets, especially interstellar ones, are masters of unpredictability. Dust and micro-impacts present an even greater challenge. No defense system can prevent meteor storms seeded by a comet's trail. Satellites could be maneuvered, shields angled, systems powered down. But if Earth were to cross a dense stream of Atlas debris, no intervention could stop the rain of alien grains. Our atmosphere would burn them before they reached the ground, but our orbital infrastructure, satellites, stations, spacecraft would be exposed. A meteor storm intense enough could cripple communications, navigation, and surveillance worldwide. The world would go dark, not from impact but from silence. And what if the hazard is not physical at all? What if Atlas carries signals, as some suspect, or broadcasts in ways we have not yet recognized? Planetary defense has no protocols for information hazards. There is no playbook for detecting, let alone containing, an alien transmission disguised as cometary noise. The risk would be not destruction, but disruption. Data that destabilizes, signals that divide, messages that exploit our vulnerabilities. Against such a threat, missiles and rockets are useless. So what do we have? We have telescopes, satellites, observers, our eyes on the sky. We have models, predictions, probabilities. We have early warning systems that can track and project, but not always intercept. We have the beginnings of space missions capable of rendezvous with comets, but not yet at interstellar speeds. We have ambition, ingenuity, and the ability to improvise, but we do not have certainty, and certainty is what interstellar comets deny us. Perhaps the most unsettling defense gap is psychological. Humanity is not united in how it perceives these threats. Some would dismiss warnings, others would amplify them into panic. Governments might conceal data to prevent unrest, or release it in ways that sow confusion. In the absence of trust, defense collapses into doubt, and in doubt, paranoia thrives. If Atlas were to erupt, fragment, or signal tomorrow, would we know the truth, or would we drown in conflicting narratives, unable to act before it was too late? The harsh reality is this: Earth cannot stop an interstellar comet. Not now, not yet. We can watch, we can measure, we can prepare for impacts of probability, but for a body arriving from another star, already here, already active, already volatile, our defences are observation only, and observation is not protection. Even with the best telescopes trained on 3i Atlas, much of it remains hidden. The comet's coma, a cloud of dust and gas, shrouds the nucleus like a veil. Our instruments can infer size, shape, and activity, but not with certainty. At the heart of the brightness lies a mystery. What is the true form of Atlas, and what does it conceal? Radar cannot reach it, the comet is too far. Spacecraft cannot intercept it, it moves too fast. We are left with indirect evidence, spectra of light scattered through dust, models of brightness variations, assumptions of density and albedo. From these, astronomers estimate a nucleus between 1 and 5 kilometers across, dark as charcoal, volatile as dynamite. But estimates are not facts. Inside the blur of the coma, there could be cavities, fragments, structures, features we cannot resolve. Even the coma itself deceives. Jets erupt from hidden vents, bending the cloud into irregular shapes. Observers may think the nucleus is intact, when in fact it has fractured, each piece cloaked in dust, masquerading as a single body. A disintegrated comet can mimic a living one for weeks before its illusion breaks. What we see is often not what is, and then there is dust, microscopic, untrackable, invisible until it burns in the atmosphere of a planet. We model streams, but our models are crude. They assume uniform release, steady jets, predictable orbits. Atlas defies those assumptions. Its carbon dioxide dominance makes its eruptions sudden and uneven. Its dust distribution is likely irregular, clumpy, chaotic. Some streams may already be crossing planetary paths, unseen, waiting to fall when the geometry aligns. Our blind spots extend further. We do not know the exact composition of its ices. We measure ratios of gases, but the nucleus holds secrets locked beneath crust. Exotic volatiles could lurk there, stable in interstellar cold but primed to explode under solar heat. If such reservoirs exist, they may not reveal themselves until perihelion, when sunlight penetrates deep. Until then, we are blind to their presence. And what of signals? If Atlas transmits in narrow bands we are not watching, we will miss it. If it encodes in polarization or dust patterns, we may never recognize it. Our instruments are tuned to natural phenomena. We look for chemistry, not communication. We may be recording data that hides patterns beyond our perception, patterns no one has thought to search for. There is also the possibility of deliberate concealment, not by the comet but by us. Governments filter information. Observatories operate under contracts. Data can be withheld, delayed, reinterpreted. What if anomalies have already been seen? Polarization shifts, unexplained radio bursts, irregular jets, and quietly set aside as noise. What if our blind spot is not technical, but institutional, built into the way we manage knowledge? The paranoia becomes sharper when we recall how Oumuamua left us, unexplained acceleration, no coma, no consensus. Its anomalies remain unresolved, yet official reports closed the book with unsatisfying answers. Borisov reassured us by looking familiar, but even it carried chemical oddities. Now Atlas presents anomalies again. Are we truly this unlucky in sampling, or are we blind to a pattern, a progression unfolding before our eyes? Perhaps the most unsettling blind spot of all is temporal. We focus on Atlas now in its brief window of visibility, but what if its dangers are delayed? What if its dust streams intersect Earth's orbit, not this year, but years from now? What if its fragments linger in resonance, only to return decades later? By the time the threat materializes, Atlas will be gone, untouchable, its origin forgotten. We may face hazards in the future without realizing they began with this interstellar visitor, and so we are left with uncertainty layered on uncertainty. We see the coma but not the core. We measure dust but not its streams. We record data, but not its meaning. Our defenses are limited not only by technology, but by what we do not know, and worse, by what we do not realize we do not know. Suppose the worst case unfolds. 3I Atlas erupts violently near perihelion, scattering fragments across the solar system. Dust streams spread invisibly, seeding meteor storms. Perhaps signals emerge, hidden in static, or patterns in dust betray intent. Whether natural or artificial, the event would leave its mark not only on the skies but on humanity itself. The first consequence is physical. Satellites, the backbone of modern life, are fragile against storms of interstellar debris. A meteor shower intense enough to scar orbital space could sever communications, disrupt GPS, cripple weather forecasting, and blind military eyes in the sky. Air travel would falter, global trade would stagger, economies would fracture in silence. Even without a single impact on Earth's surface, civilization could stumble. Then comes psychological impact. The sight of Atlas blazing brighter than any star, flaring unpredictably, fragmenting into pieces, this would stir fears older than science. Once, comets were omens of doom, their sudden appearances read as warnings from the heavens. In an age of technology, those instincts lie dormant but not erased. Panic would spread quickly. Social networks would amplify rumors. Some would call it a sign of divine anger, others of alien arrival. Governments might struggle to control the narrative. A comet could wound not by striking, but by breaking trust, sowing paranoia, igniting unrest. Scientific consequences would be profound. If Atlas revealed chemistry beyond our understanding, if its dust carried alien organics, if its activity hinted at non-natural processes, our frameworks would bend under the weight. Entire disciplines would pivot, chasing answers. The discovery of even one complex molecule unknown on Earth would rewrite theories of life's origins. The confirmation of intent, if ever admitted, would shatter the assumption that humanity is alone. Either outcome would be destabilizing. For every researcher thrilled, others would be unsettled. Knowledge itself can be disruptive. The cultural consequences may be deeper still. Humanity's stories of itself are fragile. Some cling to isolation, the idea that Earth is unique. Others hope for contact, imagining benevolent civilizations in the stars. But what if the first undeniable encounter comes not in peace, but in paranoia? What if the message of Atlas, whether real or imagined, is one of danger? Then our myths collapse. Contact is no longer a dream but a threat. The cosmos no longer a frontier, but a stage where we are observed without consent. Even if nothing extraordinary happens, even if Atlas fragments naturally and drifts away, the suspicion it stirs will linger. For decades, people will ask, was it only a comet? Did we miss something? Was the signal hidden in the noise? Paranoia will cling to every interstellar visitor that follows. No comet will ever again be only a comet. The sky itself will feel untrustworthy. And then there is the worst consequence of all, precedent. If Atlas is natural and still manages to cripple satellites, terrify populations, and fracture trust, then humanity has learned how vulnerable it is. If Atlas is artificial, then we have learned we are not alone and not necessarily safe. In either case, the precedent is grim. We will never again look at the sky as innocent. Every streak of light will carry suspicion. Every new discovery will whisper of catastrophe. The consequences ripple outward. Governments will militarize space further, citing cometary threats. Scientists will demand larger telescopes, better defenses, stronger missions. Philosophers will struggle with meaning. Religions will fracture or harden. The global population will live under the shadow of knowledge half understood, fearing what may come next. Atlas will be gone, but its ghost will remain, and that may be the final chilling consequence. Interstellar objects are not rare. Atlas is only the third we have seen. Statistically, many more pass unnoticed each year. As our instruments improve, we will detect them more frequently. The age of isolation is over. We are entering an era when the galaxy begins to reveal itself, piece by piece. Atlas is not the end of the story. It is the beginning. Paranoia rarely stops at a single object. If Oumuamua raised questions, if Borisov offered reassurance, and if Atlas unsettles us again, then the next step is inevitable. What if these are not isolated visitors at all? What if they are messengers, forerunners, heralds of something larger still on the way? The cosmos is vast, and interstellar debris does travel naturally, but three objects in less than a decade feels like a drumbeat, a rhythm too insistent to ignore. The thought creeps in, perhaps we are not witnessing random encounters, but stages in a sequence, each visitor stranger than the last, each more provocative, each demanding attention. If that is true, then Atlas is not the climax, but the prelude. Suppose Atlas is the herald of something greater, something slower, larger, or more deliberate following behind it. Comets are fast, probes or fleets might be slower. A civilization sending scouts across light years might choose objects like Atlas as vanguards, slipping ahead to test conditions. They arrive first, awaken, observe, transmit. Behind them, still hidden, comes the true arrival, time to follow the path already scouted. Even if no intelligence is involved, the paranoia still clings. What if Atlas is part of a swarm, a stream of interstellar fragments entering our system in sequence? If so, then what we have seen, Oumuamua, Borisov, Atlas, may only be the first few pieces. More could be on their way, hidden in the darkness, their paths yet to intersect with our telescopes. The worst case is not a single visitor, but a flood, a storm of alien comets, each one volatile, unpredictable, hazardous. Consider how Earth would respond if Atlas were revealed to be a herald. Panic would be magnified. If one comet can destabilize trust, what would the promise of many do? Governments would mobilize, militaries would prepare, observatories would strain to predict trajectories. But the sense of inevitability would be crushing. A single threat can be confronted. A wave cannot. The symbolism alone would be devastating. For millennia, comets were seen as harbingers, messengers of doom. If Atlas truly were a herald, whether of natural swarm or alien intent, ancient superstition would find itself vindicated. Fear would not be confined to the scientific community. It would spread through culture, religion, philosophy. Civilization thrives on the illusion of permanence. A herald strips that away. What if the herald carries not only warning, but purpose? Suppose Atlas's activity is not just observation, but preparation. It may be mapping gravitational corridors, testing solar responses, seeding dust with information. Its role could be to prepare the environment for what comes next, laying trails, scattering signals, leaving markers. The main event may be invisible still, but Atlas would have paved the way, and the darker thought follows, what if heralds are disposable? Oumuamua slipped through silently, Borisov burned brightly, and left. Atlas flares violently, perhaps to fragment. Each one may be designed to end itself, sacrificing its body for its role. What if this is their function, their fate, to enter, to act, to dissolve, leaving behind the true message that something else is coming? The paranoia crystallizes in a single question. What if Atlas is not the threat, but the announcement of the threat? A trumpet in the void, a flare in the dark, a herald declaring that the age of solitude is over. If Three-Eye Atlas is not the end but a beginning, then the question deepens, what comes next? For some, the thought is statistical. Interstellar space is filled with debris, and the more we look, the more of it we will find. Atlas may simply be one of many, the latest in a sequence that will stretch across centuries. But for others, the sequence feels purposeful. Oumuamua in 2017, Borisov in 2019, Atlas in 2025. Each one stranger, each one harder to explain. If this is not chance, then perhaps it is choreography. What might follow choreography? A pattern unfolding step by step. Oumuamua was silent, barren, confusing. Borisov reassured us with familiarity, a comet like those we already knew. Atlas unsettles us again with violent activity and alien chemistry. The next visitor may be stranger still, larger, more deliberate in its anomalies. A body that leaves no doubt it is not simply natural. The progression is escalation, and escalation rarely ends in calm. Perhaps the next will not be a single comet, but a swarm, a cluster of interstellar fragments entering together, a storm of bodies, some bright, some dark, each carrying its own chemistry, each demanding attention. Imagine the sky filled not with one anomalous visitor, but with many, a fleet of messengers sweeping past the sun in succession. To observers, it would be the most extraordinary astronomical display in history. To those seeking patterns, it would look like a rival. Or perhaps what follows is not another comet at all. Perhaps Atlas is the decoy, the distraction, drawing our telescopes and instruments while something slower, larger, less visible slips into place. An object of metal, not ice, a vessel, not a relic. It would not appear in our comet catalogues, because we are not looking for it. Our eyes follow the bright coma, the dazzling tail, while something darker hides in its shadow. Even without such speculation, the natural progression is daunting. Each interstellar visitor teaches us how little we know. Each forces us to expand our definitions. The next may force us to break them entirely. If Atlas is volatile rich, what of a body rich in elements we have never seen? If Atlas is fragmenting, what of one that refuses to fragment, holding its shape against all reason? If Atlas is merely kilometers wide, what of one tens or hundreds of kilometers across, a true giant from another star system? The cultural consequences of what comes next may be greater than the physical ones. Humanity is just beginning to grasp that the galaxy is not silent. To face another interstellar visitor so soon will reinforce that truth. To face one more dramatic, more dangerous, more anomalous than Atlas will force us to reckon with it. We will no longer be able to hide behind coincidence. We will no longer be able to say these objects are curiosities. They will become part of our reality, our threat assessments, our stories of ourselves. And the darkest possibility lingers still. What if Atlas is not only a herald but a signal, a flare announcing that our system is open, that it is time for the next step? If something follows, it may not be natural, it may not be benign, it may not even be distant. It may already be on its way, hidden in the noise of the sky, its presence masked by coincidence, until the moment it chooses to reveal itself. If Three-Eye Atlas is a herald, then the most unsettling possibility is that it does not announce mere coincidence or discovery, but contact, and not the contact we imagine in hopeful science fiction. No handshakes across the stars, no exchange of knowledge, but confrontation, sudden and uninvited, shaped not by our terms but by theirs. Imagine that Atlas is more than a comet. Imagine that within its nucleus, sensors have awakened, listening to the electromagnetic hum of Earth. Imagine that its eruptions, seemingly random, are modulated bursts of data reporting back across light years. If so, then its role is complete. It has seen us, it has heard us, and it has told someone else that we are here. What happens next may be confrontation, not with Atlas itself, but with what it has summoned. Perhaps the confrontation comes not in ships, but in signals. A sudden flood of transmissions, beamed at Earth from unknown coordinates, carrying data we cannot interpret or cannot ignore. The first interstellar reply, arriving not as peace but as challenge, overwhelming our systems, destabilizing our cultures. Even without weapons, information alone could fracture us, dividing trust, shaking certainty, collapsing order. Or perhaps confrontation comes in fragments. If Atlas were to disintegrate deliberately, scattering debris into orbits calculated to intersect with planets, then the disaster would appear natural, unavoidable. But beneath the illusion, it would be targeted, fragments seeded where they would cause maximum disruption. Impacts on Mars could cripple our outposts there. Streams of dust could blind our satellites. Earth might never be struck directly, yet the confrontation would be total, stripping our reach into space, cutting our eyes from the sky. The paranoia sharpens when we imagine confrontation as a test. Suppose Atlas is not here to destroy, but to measure our reaction. How quickly do we detect? How do we respond? Do we panic or do we organize? The confrontation is not with ice and dust, but with ourselves, our fear, our divisions, our fragility. If this is a test, then the graders are elsewhere, watching, waiting to see whether humanity can survive even the suggestion of a threat. And yet, confrontation could be simpler still. Perhaps Atlas is not announcing but embodying. Perhaps it is itself the contact, an alien machine disguised as comet, not carrying signals but carrying presence. If so, then every eruption, every fragment, every dust storm is not only hazard but intrusion, the touch of another intelligence cloaked in cometary form. We would not know it. We would measure gas ratios, plot orbits, write papers, all while the true confrontation unfolded unnoticed. What does confrontation in the void look like? It may not be war, it may not be fire and weapons, it may be silence, observation, subtle manipulations of dust and plasma, invisible until consequences unfold. It may be knowledge withheld, anomalies dismissed, truths hidden from the public. The confrontation may already be happening, not in the heavens but in the way we interpret them. If this is the worst case, then Atlas is not merely a comet passing through. It is the opening move in a game we did not know we were playing. The confrontation may not peak in our lifetime. It may unfold slowly, through more visitors, more anomalies, more heralds, but the trajectory is clear. The age of innocence is over. We are no longer unobserved. The void is not empty. Something has noticed us. If 3i Atlas is the opening move, then the sequence must have an endgame. Contact by confrontation implies escalation, a rising curve of events that begins with subtlety and culminates in clarity. The unsettling question is, what does the climax look like? When the galaxy stops watching and begins to act, what form does that action take? One possibility is direct arrival. If Atlas is a herald, then what it announces may be slower, larger craft following behind. These might not travel at comet speeds, but at deliberate, engineered velocities. They would not blaze with tails or flare with jets. They would appear silent, dark, unreflective, designed not to dazzle telescopes but to evade them. We would not see them until they wished to be seen. Atlas's flares, its dust, its spectacle, all could be camouflage, drawing our instruments while something else slips quietly into the inner solar system. Another possibility is delayed consequence. If Atlas disintegrates into fragments seeded across planetary orbits, then the action of the galaxy is not immediate but inevitable. A fragment returns years later, striking Earth or Mars, its origin forgotten. The destruction appears random, natural, unlucky, but in truth it would be the final stroke of a plan written long before we were watching. The act is not sudden arrival, but patient inevitability, catastrophe disguised as chance. Perhaps the galaxy acts through information, not matter. If Atlas carries signals, then what follows could be a reply, not in months or years, but in centuries, when the transmission it sends outward is answered by another probe, another herald, another visitor. The confrontation would be drawn out, longer than human lifespans, but relentless. We would live under the knowledge that the first move has already been made, and that what comes next is only a matter of time. But the darkest scenario is that the act has already happened, that Atlas itself is the action, that when it erupted, when it scattered dust and gas, when it flared unpredictably, it was not just cometary behavior, but the release of something else, nanostructures, signals, engineered organics already drifting through our solar system now. If so, then the climax has already occurred, invisible, unnoticed, mistaken for nature. The galaxy has already acted, and we are already living in the aftermath without realizing it. To imagine the galaxy acting is to confront our powerlessness. We cannot intercept interstellar comets. We cannot decode signals we do not recognize. We cannot shield the planet from dust storms seeded across millions of kilometers. Our defenses are designed for asteroids and local comets, not for messengers from the stars. If Atlas is part of an act, then we are spectators, not participants. And yet there is another possibility, more unnerving still. Perhaps the galaxy's act is not hostile at all. Perhaps it is indifferent. Atlas may be one of countless probes drifting between stars, sampling, transmitting, observing, never caring whether the civilizations it brushes past survive or not. The confrontation is not war, but irrelevance. The act is not attack, but neglect. For a species craving meaning, this would be the cruelest revelation that we are seen, but not significant. Still, paranoia lingers. If Atlas is the third step in a sequence, then the fourth may be decisive. We wait, we watch, we speculate, but the truth is beyond our control. The galaxy acts at scales we cannot counter, on timelines we cannot match. Atlas is only the reminder, the visible piece of something larger. Its passing is not closure, but opening. When 3i Atlas finally sweeps past the sun and drifts outward again into the dark, humanity will be left staring at the silence it leaves behind. For months we will have tracked it, debated it, feared it, and then, like every comet before, it will vanish from our skies, fading into invisibility, its path carrying it away from us forever. But its departure will not erase the questions. If anything, it will sharpen them. The scientific community will publish papers on its composition, its dust, its anomalous activity, ratios of water to carbon dioxide, models of its fragmentation, estimates of its nucleus size. The data will be archived, the observations catalogued. In time, the comet will become a reference point, a case study in interstellar chemistry. But beyond the academic pages, the memory will persist differently. To the public, Atlas will remain an enigma, a question never fully answered, a visitor whose motives, natural or otherwise, were never entirely understood. The world will carry scars, even without direct impact. Satellite constellations may have been disrupted by dust. Meteor storms may have flashed across the skies, dazzling yet unnerving. Economic systems may have trembled at the prospect of fragility. And perhaps most deeply, our confidence in cosmic stability will have cracked. We once imagined the solar system as our home, a stable cradle. After Atlas, we will know it is porous. The galaxy is not outside, it is here, brushing against us. Culturally, the shadow will be long. Artists, writers, filmmakers will seize upon the imagery of a visitor from the stars, half comet, half machine, half omen. Religions may splinter or bloom with new interpretations. Was Atlas a sign of judgment, a messenger, a warning? Political movements will twist its meaning, some demanding greater investment in space defense, others arguing for cosmic humility, still others denying it was ever unusual at all. The comet will not leave cleanly. It will linger in the stories we tell, a permanent part of our mythology. And then there is paranoia, the style of thought that Atlas itself provoked. Even after it is gone, we will wonder, did we miss something? Was a signal hidden in the noise, overlooked in the data? Did a fragment remain in orbit, too small to see but fated to return? Did it seed something in our skies, our atmosphere, our soil? Every anomaly in years to come, every sudden meteor storm, every satellite failure, every unexplained radio burst, will be linked in whispers back to Atlas. It will become a touchstone for suspicion, a permanent thread in the tapestry of unease. Future interstellar visitors will be judged against it. Each detection will bring echoes. Is this the fourth in the sequence? Will this one be stranger, more dangerous? The discovery of Oumuamua startled us. Borisov reassured us. Atlas unsettled us again. What comes next will not be seen in isolation, but as continuation. Atlas will define the pattern, the benchmark for paranoia in the sky. And for those who lean toward darker interpretations, Atlas will not truly have departed. They will argue it has left traces, that its departure was only apparent. Dust in resonance with Earth's orbit, fragments seeded near Mars, signals still echoing through the magnetosphere. In their eyes, Atlas is not gone. It is here lingering invisibly, its presence woven into our future. This is the quietest yet most dangerous aftermath, because when the object is no longer visible, imagination takes over. Fear thrives in absence. The less we can observe, the more we invent. Atlas will recede into the dark, but in the human mind it will remain, an eternal visitor. Long after 3i Atlas has slipped back into the abyss between the stars, its influence will linger. Its physical body will be gone, invisible against the void, but its legacy will echo through science, politics, culture, and philosophy. Every interstellar visitor that follows will be compared to it. Every anomaly will be measured against its unsettling record. Atlas will be remembered not only for what it was, but for what it forced us to confront. Scientifically, the legacy is clear. Atlas will anchor a new era of interstellar astronomy. Oumuamua began it, Borisov confirmed it, but Atlas expands it, demonstrating how violently alien comets can behave, how unpredictable their chemistry may be, how dangerous their debris could become. Research funding will surge for telescopes capable of detecting interstellar objects earlier, at greater distances. Missions will be designed to rendezvous with them, to probe their cores directly. Atlas will become the case study cited in every grant proposal, the justification for every new instrument. It will have transformed our science, not by answers but by questions. Politically, the legacy may be sharper. Governments will recognize that Earth's vulnerability is not limited to local asteroids. The idea that hazards can arrive from outside our system will reshape planetary defense strategies. Budgets will shift toward interstellar monitoring, early warning systems, rapid response missions. Some nations will frame Atlas as a cosmic threat, others as a cosmic opportunity. Either way, the comet will have entered geopolitics, a visitor turned into policy. Culturally, Atlas's legacy will be mythic. Humanity has always woven comets into stories of doom and wonder, and Atlas will be no exception. Its interstellar nature will give it a special place, a symbol of intrusion, of otherness, of the galaxy reminding us that we are not alone. Writers will cast it as omen, filmmakers as harbinger, musicians as muse. Long after its tale has vanished, its image will glow in art, a permanent character in our imagination. Philosophically, the legacy may be deeper still. Atlas forces us to ask whether we are ready for the galaxy to notice us, or whether it already has. It blurs the line between natural and intentional, reminding us that what seems random may not be, and what seems deliberate may only be coincidence. It exposes how fragile our certainty is, how quickly suspicion takes root, how little we trust our own narratives when the sky itself becomes strange. And there is the paranoid legacy, the most enduring of all. Atlas will seed the thought that interstellar visitors are not just debris, but potential messengers, sentinels, or heralds. Even if every anomaly is explained, the suspicion will remain, because the sequence itself, Oumuamua, Borisov, Atlas, feels too much like escalation. People will wonder if the fourth will be stranger, the fifth more dangerous, the sixth undeniable. Each new discovery will reignite the memory of Atlas, feeding the sense that something larger is unfolding. In practical terms, its legacy may shape our path into space. If dust from Atlas scars satellites, we will build stronger shields. If its debris threatens Mars, we will rethink colonization. If its anomalies hint at signals, we will expand SETI to watch not only the stars, but the visitors that pass between them. Atlas will not just have brushed our skies, it will have redirected our trajectory. Perhaps its greatest legacy will be psychological. Before Atlas, the galaxy felt distant. After Atlas, it will feel immediate. The void is no longer empty. The walls of our solar system are no longer impermeable. Something has come through, and more will follow. Humanity will live with that knowledge forever. When the comet has gone, when its dust has thinned, and its orbit has carried it beyond the reach of our telescopes, humanity will be left with silence. Yet in that silence lie lessons. Lessons written in gas ratios, in violent eruptions, in unanswered questions, in fears that stretched beyond the scientific into the existential. Atlas will not only be remembered as a visitor, but as a teacher. The first lesson is humility. The solar system is not a fortress. The universe is not distant. Atlas arrived from another star, uninvited, unstoppable, unknowable, until it was already upon us. No wall separates us from the galaxy. The abyss is permeable, and what moves in it can reach us. Humility means accepting that we are smaller than we wish to believe, less defended than we imagine, more vulnerable than we admit. The second lesson is vigilance. We cannot afford to dismiss anomalies. Oumuamua was puzzling. Borisov was familiar. Atlas was unsettling. Each demanded attention. Each raised questions. Each revealed our blind spots. The lesson is that the cosmos is not quiet, and vigilance must be constant. Our instruments must sharpen. Our models must adapt. Our minds must remain open. The next visitor may arrive sooner than we think, and it may carry mysteries greater still. The third lesson is unity. Interstellar comets are not national problems, they are planetary. No nation can stop them, no government can own them. Their presence concerns all of us, equally, simultaneously. If Atlas taught us anything, it is that our divisions make us weaker, that our distrust leaves us blind, that our survival may depend not on missiles or money, but on cooperation. If we cannot face the sky together, then we will face it alone. The fourth lesson is acceptance of ambiguity. Atlas may never yield full answers. Its nucleus may remain hidden, its chemistry debated, its anomalies unexplained. We may never know whether it was entirely natural or something more. But to live with uncertainty is to live with reality. The universe rarely offers clarity. Atlas forces us to dwell in mystery, to acknowledge that some truths remain out of reach, and that speculation itself is a way of navigating the unknown. And the final lesson is perspective. For all its dangers, Atlas was also a wonder, a fragment of another world crossing our sky, glowing in our telescopes, a reminder that the galaxy is alive with motion. To fear it is human, but to marvel at it is also human. Its passing connects us not only to risk, but to awe. It shows us that we are part of a cosmos vast and restless, a cosmos that will not leave us untouched. In the twilight of its passage, these are the lessons Atlas leaves us: humility, vigilance, unity, ambiguity, perspective. They are not answers, but they are guides, ways of facing the unknown, ways of enduring the suspicion that the universe is stranger than we hoped. In the end, Three-Eye Atlas will fade into the darkness from which it came. Its tail will thin, its coma will vanish, and its nucleus, whether fractured or intact, will glide silently beyond the reach of our eyes. The visitor will have passed, leaving behind no orbit, no return, no promise of another encounter. Only questions, only echoes, only the faint memory of light in the sky. And perhaps that is the final truth of Atlas. For all our speculation, for all our vigilance, for all our fears and hopes, it was never ours to keep. It was a traveller on a path older than our species, older than our sun, older than the earth itself. For ages it drifted in the dark between stars, unseen, unremarked, carrying within it the frozen archive of another world. Its brief passage through our system was not for us. It was simply motion, continuation, journey. Yet we saw it. For a moment in cosmic time, our instruments tracked its orbit. Our telescopes captured its glow. Our minds spun stories around its presence. We measured it, debated it, feared it, imagined it. In doing so, we revealed not only the nature of the comet, but the nature of ourselves, our hunger for meaning, our fear of intrusion, our hope for connection, our unease in the face of mystery. Atlas was a mirror as much as it was a comet. In it we saw our vulnerabilities, our paranoia, our awe. As it drifts away, we are left with silence. No catastrophe has struck, no revelation has arrived. The world continues, as it always does. But something has changed. Quietly, invisibly. We know now that the void is not empty. We know that interstellar visitors will come again. We know that the boundary between natural and intentional, between safe and hazardous, between silent and signalling, is thinner than we once thought. And so we return to calm. The worst case did not unfold. The herald did not reveal its master. The signals, if they existed, were hidden in noise. Atlas departs, and we remain. The sky is quiet again. The fear recedes. The paranoia softens into memory. What lingers is the awareness that we are part of a wider stage, a cosmos filled with wanderers, some innocent, some uncertain, all reminding us that we are not as alone as we once believed. Tonight, if you step outside and look up, the stars will seem steady, the planets will shine as they always have, the sky will feel familiar. But somewhere out there, faint and fading, Atlas is still moving, still drifting, still carrying with it the frozen secrets of another world. It is gone, but it is real. And knowing that it has passed, knowing that it was here, knowing that others will follow, that is enough. So let us end not in fear, but in quiet wonder. The galaxy is vast, and its visitors are few, but they come. They remind us that we are seen. They remind us that we are vulnerable, but they also remind us that we are part of something greater, something immense, something that stretches beyond fear into awe. Atlas has passed, and we remain, waiting for the next echo from the stars.